Okay. Let's start that and start this. Shit. Okay, let's see. Okay, let's see. Time. Do a ping. Okay, and I will take all of the chats. Hello, greetings, great brother Kit the Cat and Chupak. Yeah, I'm a bit late with the stream today. I spent hours trying to fix the Discord bot. I had to move it to another hosting providers or like another host, and I've messed up the database. So yeah, it's not good. But I have a backup, but I'm still unsure. Like I can't get it correctly working. But it's okay. I will fix it another time. So now, for now, the bot is just reset with all of the stats. Damn, T is great. All right. Yeah, I just did the thumbnail. Are you using GLM or something similar for 3D? I'm actually using. I have a friend who made a math library for SIG, so I'm using that and I'm modifying it slightly as times go on for things that I need. We can see here. It's basically this thing. So, not really GLM, but it's a custom math library that a friend has made, and I'm just slightly tweaking it if I need something. Yeah. That, basically. I actually think I will plug in the VR headset. Forgot about it already. Bruh. So, and then I'm gonna take it from over here. I should vacuum, there's like dust here. Welcome. I want to go in. Like so. Time. Alright. Woo! Shoo! So I'm gonna go to projects, Wallenstein, and where we left off last time. Let's take that. We can close this. Wallenstein, let's go. I'm gonna start not verbose, I'm gonna run with null this time because then I can get the actual VR headset running like so. Oh wow, that was a lot of red messages. Yeah, the handles make sense that they can't find those, but everything else should still be found. Let's see. Sig build run. Everything should run, yes. And then we have the headset, which we see the triangle right there. Where? Well, why is it going so crazy? It's not a good idea to have everything on. I think it's fucked. Oh no, I'm just looking at it wrong. Yeah, now it's correct. Okay. Everything is fine. Everything's fine. Oh god. Alright. Okay, now. Alright, so yeah, hello pig, and easy effect installed? No, I think we will use SDL for the audio. Now that we have a clear color and depth working, we can now start to render geometry in our scene. We will use graphics API to create the vertex index, uniform constant buffer, along with shaders and pipeline to render some cuboids represent the floor and table surface. Update the method member in the class. Copy the highlighted code. Create resources, destroy resources. Interesting. Why would you? Render cuboid. Okay, so now they just create a function to do all of this stuff. Vertex buffer, index buffer, uniform buffer, camera. Yeah, okay. Normals. Yeah, I already got that, and that I also got. To draw our geometry, we will need a simple mathematics library for vectors, matrices, and like. Download this header and in common folder. Linear algebra. Bro! CodeFox. In main CPV, add the following code. Whoa. Are you blind or what? Who? The current header include the statement. That's not something I'm gonna do. I think I have it already also. Oh yeah, it's just operator overloading. Bruh. Now we'll need to set up all of our rendering resources for our scene. Yeah, I saw I said hello. I don't write in the chat. Now we'll need to set up all of our rendering resources for our scene. Maybe the mic went off when I said hello. I don't know. This consists of a... Wait, what? Now we set up all of the rendering resources for our scene. This will contains the vertex buffer, index buffer pair that holds the geometry data for a cube, and a uniform constant buffer large enough to hold multiple instances of our camera constant struct. enough to hold wait, what? Geometry data for cube and uniform constant buffer image buffer large enough to hold multiple instances of our camera constant. Struct we use graphics create buffer to create and upload our data to the GPU. Above void create resources, add the following code defining camera constant and array of. So, wait, they have the view projection view model. Yeah, I don't know why you would name it like that. Feels a bit weird, but sure. And then what are these? Camera constants and then normals. Would they pass them in just like that? Hello, T-Chef.
I finished everything that I need to do today. Now
Amazing.
I have complete time.
These are the normals for the cuboids. So you have like each face here. So you can get the lighting working correctly. You have.
Are you doing a camera right now?
I do already have the camera, but I'm adding 3D now, and I'm just trying to understand what they're doing here. Like, okay, so this is like kind of like left, right, X, so right, left, and then this is X, Y. So then this is back, forward, and then you have white set. So you have up and down, depending on how your camera is oriented. This could be different, all of them, or where it's placed. Copy the following code into create resources. So vertices for a 1x 1x meter cube, left, right, top, bottom, front, back. So this is all of the vertices. This is actually like you need 8, right?
Has like 5 XR vector.
Sorry? Yeah, XR vector. Yeah, crazy stuff. I think they actually have it's actually is it actually provided? If I do c.xr vector, oh yeah, it actually exists. It's crazy. But yeah, so these are all of the vertices for a cube, and then what is this define cube face? No idea. And then cube face, and then you give the oh yeah, wait, how does oh no. Oh god. Why would you write it like that?
I also don't understand this.
Yeah, I don't know. This like why not just use it like this? I would prefer this. This is more logical than trying to having to read the define. So you can read this, so you then can that. And then cube indices. You give all of the indices. Yeah, but why would you? Why are they?
Yeah, that's you know what that's so dumb what they're doing, or like not dumb, but
yeah,
they're using like the vertices and then make with that define like the big list of vertices with like, so they don't need any indices and they just use the indices. Yeah, so you could
literally just say like this. You don't. Well, I guess yeah, it's a bit.
Yeah.
But still, I don't know, man. And then vertex buffer, create buffer, and then you pass in these things, and then that a number of cuboids, Q. So uniform buffer camera. I will add the code to load and create our shaders with. Well, I already have shaders, so I don't. This is already implemented for me in my own way. Now we will combine shader, the vertex input layout, and rendering state for drawing a solid cube into the pipeline object using create pipeline. To destroy the resource destroy the resource, this code into destroy resource which uses corresponding graphics destroy method. And then you just destroy all of these at the end. With our rendering resource now set up, we can add the code need. Wait, with our rendering resource now set up, we can add the code needed for rendering the cuboids. We will set up render cuboid method, which is a little help method that renders a cuboid. It also render cuboid with rendering cuboids index. This is used so that we can correctly index into the right section of the uniform constant buffer for positioning the cuboid and camera. Render cuboid index inside render cuboid. Create translation, rotation, scale. Yes, multiply camera view. Model, camera constant controllers, size offset camera, set pipeline. So set, they have a like set pipeline. Interesting. Graphics set buffer data. And set the data, okay. Set descriptors. Yes. Update descriptor, set vertex buffer, and then set index buffer, and then draw index 36. Render cuboid index plus. Yes, okay. I'm just trying to see like slightly how they have designed this whole thing so I can easily connect it with what I'm supposed to do. From the past in pose and scale, we create the model matrix and multiply it with the camera constant view to obtain constant the matrix, the transformation, the vertices in our unit cube from model space into projection space. Apply our pipeline which contains the shader and the render states. We update the two uniform buffers, one containing the camera constants for the vertex shader and the other containing the normals for the cuboid. We assign the vertex an index buffer and draw 36 indices. I can't numbers, bro. Moving to render layer method under the called clear depth and before the called render and rendering. Set render attachment, set viewport, set scissors, computer view projection transformation. All matrices including OpenX are column major right-handed. View scale. This section sets the color and depth images views as attachments for output merger color blend stage to right. So set viewport for the rasterizing to transform from normal device coordinates to texel space, and we set the scissors for rasterizing to our cut in the texel space. Our viewport and scissors cover the whole render area. Next, we compute projection and the view matrices, and we will multiply them together to create a view projection matrix for camera. Whoa, did I go down? Camera constant. Okay, I'm not going down. I'm not going down. Add the following code: render cube index draw floor scale by 2 at x. Okay, so now you render each of them. Okay. Finally, set render cuboid index to 0 and call render cuboid twice, drawing two cuboids. The first is offset by our arbitrary new view height to represent the floor. We scale it by 2 meters in the horizontal direction and 0 in the vertical so that it's flat. With that, we should now have a clear color and 2 cuboids rendered to each view in your XR system. Yavny Pants 5000 at Twitch says, "Hello from US. I am Sig Noob here to learn." Well, welcome aboard. I'm also a SIG noob. This is my first SIG project, so I don't know if you can learn much from me. I'm probably doing everything wrong, but it runs, so does it matter? If it runs, it runs.
Works, it works.
It worked, it worked. Yeah. Our X application now renders graphics to the view and uses the XR compositor to present them correctly. He also has a SIG project as well, and it runs. Yay! No shame in working code, exactly. Or was a present graphic reviews and uses XR composition to present them correctly. In the next chapter, we'll discuss how to use OpenXR to interact with your XR application, enabling you new experience in spatial computing. Below is a download to the. Okay. And I think I kind of see the overview of how all of this is supposed to be set up. A little bit confusing again with C++ and its classes that just does stuff without you. Yeah, it just does stuff. I'm not gonna end it there. But yeah, let's see, file. Yeah, you guys won't see this, but that's okay, don't worry. I wonder, should I have it in? Probably left it in here. No, where am I doing? What am I doing? Downloads. And then triangle. Where? There it is. Open that. Open. Okie dokie. So, you're doing your own Vulkan renderer? Yes. Let's see. I think we probably create something similar like to this. But this only has to be initialized once, and then we can use it whenever we want it. And right now, the whole thing is just ugly as hell. But as I said, we will get the basic stuff working, and we will modularize this. I think. Will I go through this whole thing before I start to modularize stuff? Maybe not. Preferably not. I would think after I have gotten this 3D stuff up, I would like to put stuff in. I would actually like to be able to interact with the stuff, and then I will modularize it. Yeah. So we're gonna be say const. We will probably not change these values. No, we will only scale. Maybe we need to make it. Yeah. And then, so we'll do this, that, and then like so. And am I not allowed? Isn't it supposed to be? It's like this, yeah. I always forget. Fuck. Oh. And yeah, then, oh no. Then all of these F's needs to go. So I'm gonna replace string F with nothing /G. Can I do that? Is this okay? What if I do that? Yeah, let's do that. And then if I say it will automatically, yeah. So we'll just store it like that. And then we will create this. In SIG, I don't know, can you do const x? I'm not sure you can. I will just say const. Once again, do this. And then this c dot this. And this one do the same thing. Just gonna put a comma here, otherwise it will not be funny. And like so. And yeah, you cannot have any plus signs apparently. So I will just replace all of the plus signs. Oops. Those. Oh, with that. So, and then right. So, and then go here, and we will. Oh no! We'll do this. String replace f with this. Boom. I guess comp time values are like context group values in C++. Yeah. Yeah, I guess I'm not really sure how SIG works to 100%. Like I'm just learning it, and let's see. Can I? Not really sure, but I guess they have to be. We should have one of the SIG guys now here to answer this question.
Like Harold always says that home time is like so much more than like home time.
Wait, what? Comp time is so much what?
More than just like doing things compile time, I don't know.
Yeah, like you mean runtime, that you do them during compile time. Oh yeah, there is like a lot of things you can do. Like, isn't there like a field you can create that does things during compile time? So if you wanted to do some equation or something like that, you could just do it during compile time and then just keep the result for whatever.
Yeah, I don't know. Well,
Yeah. But why did they? Okay, so wait, you have the position, right? This thing's like, why would you do it like this?
to be honest, I would just not do it like them and just use indices that are
like a normal programmer. Like,
yeah. Like why would you use indices then? Like
yeah,
indices are exactly for that purpose. Like it's so
exactly.
crazy. Yeah, but if you do it like that, you need to
I need to update.
indices yourself, which is like
But I can still like
very tedious.
yeah, but it's okay. I can just wait 0 1. Am I thinking right? I think I'm thinking right in the right like kind of way, right? Am I tripping right now?
Like to be honest, for me it would be the easiest to just draw the thing with like the vertices, or like have them like front face first one or so. I
It's
don't
kind
know.
of yeah, like still naming maybe like you can. Wait, what?
But it's kind of hard to name them like because it's a cube, you know.
But
Like
this one is just if you think about it, plus plus plus. So this is like top front right. Fuck, this is gonna be awful.
like it's yeah. So that's because like you should draw them.
How do you mean?
Just draw the cube.
There is probably just wait. I can just put this in AI straight up, and it can just give me the right
Yeah,
answer.
probably.
Like this is why you should use AI for this kind of things, right?
But one time I really just did it myself and
Yeah.
spent like probably 10 minutes drawing it and like getting all the triangles. Like I didn't even have the vertex positions. Just yeah. I messed up it quite a bit, but after that I fixed.
The vertices and indices for a cuboid. Can you?
Cuboid.
I don't know how to spell it. So can you fix the data to be correct? I think it will understand what I mean by that. Like it's
Yeah.
oh no, don't tell me it started to. analyze my comments. Okay, it did actually. No, what? Okay, okay, okay. So yeah, it actually understood that this was what I was thinking of. Okay, it actually understood that was what I meant by that comment. Pretty cool. Okay, I will just
Yoink.
yoink that, and then here let's see. I think this should be also correct. Fuck. I don't like. Let's see. It's a little bit more compact. Okay, let's see. So front face. So that takes number 4, which is. They should all be front. All of the fronts. So it goes 4, 6. So you have the top left, and then you have bottom left, and then it should take the right. Yeah, okay, it did like this. So it has that triangle, and then there, and then it takes 6, and then 2. So yeah, that's the other one. Okay. And then we have back is 1, 3, 5, and 7. Yeah, it seems to be correct, all of these. 5, 4.
Yeah, I will see in the rendering.
Yeah, we can also just see in the rendering, but I'm just checking that. Well, unless if these are incorrect, this will not. At least the data between these two seem to match. But if this is wrong, fuck. But they seem to be correct. So let's just roll with it. What did you say?
I think it got the Vulkan axis right, which is kind of interesting because because you're using XR vector, okay.
Yeah.
But that doesn't mean, because in OpenGL and Vulkan the Y coordinates are swap.
Oh right,
So,
I forgot. Wait, wait. Is it like Vulkan coordinates? I guess you can find.
yes.
Uh,
It's like X is like from -1 left to 1 right, and
Yeah.
Y is like from -1 bottom to 1 top.
Is it Y? Yeah, because Z is the depth. Yeah.
Yes. But in OpenGL it's like 1 is like bottom right, and then Vulkan 1 is top right.
Damn. That must be, if you do something that works for both of the application, that must be pain to remember. Well, I guess you could also just flip the camera. Nah, I don't know, man. I wouldn't flip the camera. Let's see if this compile. I'm not using it, but it should at least compile, right?
I'm not using.
Yeah. Should I switch my headset to look this way so we can also see the triangle? Hell yeah. Let me put up. Wait.
Do you have your headset on right now?
No, I have it on my behind me. Yeah, it's not that good at tracking it apparently. These stations, it's going crazy. That's okay.
How do you look around?
Sorry?
How do you look around? With like these hand sticks or?
No. You just look around with your headset. You literally just move around and you will look around.
Yeah. So if you just moved your headset in real life.
Yeah. Then it will move here as well. But yeah, let's see. Maybe I have to see. Maybe I can still get those runtime controllers. I have to check that I can interact with shit, because then I could move shit, you know. So yeah. Yeah, we're gonna continue just adding shit into this 1000 line main loop. I will move shit away from it soon.
I thought you had done some refactoring, and I see a 1000 line main file.
I have done a little bit of the XR swap chain, which is okay, it's just 300 lines, and then the Vulkan swap chain. So I moved a little bit from these places to just these ones, which should be fine. But I still want to move a lot. I want, for example, to move the SDL away from here and probably do some of the rendering as well. Like,
Yeah.
maybe even put actually like all of these, except for the main function, away from here, just to put it in a engine or renderer or something like that. And then, yeah, based on that, just do shit. Thunder. Alright. So, then they create this thing and they pass in, so they create these buffers. I have the code. What is the function? Create buffer. Okay, I'm gonna actually open the... Right.
Is it just creating a Vulkan buffer?
Wait, let me... And then... Okay, I'm gonna do something crazy right now. I'm gonna go here, cd downloads. I want to see how they like create all of these stuff, because that's like an API call to...
Yeah, for the graphics thing that you get like in the common files, right?
yeah, wait, I got the common here, but I want to move this one. So move... Wait, which one was it? Open XR Explorer, and oh, that was it. Example to common. Bruh. Okay, this is... Oh, it's capital C. I was like, why is it not finding it? And then, now it should be here. Yes, there it is. So now I can just check that out at the same time, do some comparisons. So let's see. Create that command or that buffer, which should be in the Vulkan API call here. Let's see, create buffer here. Whoa, that doesn't look same at all. They take in one parameter, which is the create buffer info. What?
Yeah, but the create buffer info can have like all the necessary things.
Yeah, but
Wait, but their function where it showed in your stream, does it just create a Vulkan buffer?
let me... I can actually maybe... I'm thinking. I will put this number here, and then I will take this one over here. So they have... Bruh. Wrong buttons. Everything wrong. Okay, good. So they have this. Well, actually, it's first called through the graphics API here. Bruh. Don't know why it's not highlighting, but yeah, create buffer. Come on. Okay. Then it's... Oh, yeah, because it's probably virtual. Yeah, here. But that's not the same parameters that I read here. That's why I'm getting confused, like... The fuck? Am I...
Wait, why isn't it the same? Doesn't it also in their thing don't only take in create buffer info?
Let's see if we actually go to this thing and read here. So here they take... No, that's the Vulkan. What? Okay, now... Do I have the right version of this thing? Which example version is this? Just say example, but I think it's the number 3. Well, we can figure this out by copying this and putting this here. Okay, I have the wrong version, that's why. Trollolol. Okay, and then I can copy... What was it called? It was called chapter 3. Move chapter 3 to common cd common, and actually let's rm. I don't need the old one anymore, I can just remove it. I don't remember the OpenXR example CPP. That, and then it's a zip, so just unzip. Chapter there. Oh wow. That's fine. I don't really care. And then I can start code, and we can close that, and then with a open folder, downloads, common, open that. Oh wait, you get the whole common here as well, so maybe it's a bit dumb for me to... Okay, interesting. I thought they wouldn't come in the... I didn't think they would come in the same. Because now I have common and common, which is kind of stupid.
Uncommon.
Uncommon, yeah. Bruh. But where do we have the actual main function? What?
Do they even have a main function? I thought they only provide you with like a class with like working functions.
No. Okay, let me just... This is... what am I doing? Let me just... cd common. And then I will move chapter 3.zip one step out, and then rm, rf, everything inside of here. Then we will move this one. Well, I will just make a dir OpenXR example. Move chapter OpenXR example. Oh, I have the tut. Maybe it's there actually. Bruh. Unzip. And now, let's see. But this one should have the main, shouldn't it? Am I actually this stupid? Graphics. App. No? Source. Main.cpp here. Bruh, that took for too long. Okay, so now if you search for this thing, create buffer. They do this here, they pass in 3 arguments. Yeah, they pass in what type it is, and then they have the size of it, and then they have how many.
Yeah, but they have it in the like constructor of the buffer create info thing, you know? So it's like only one parameter. But like it's the struct.
Oh
or
wait,
like class, I don't know.
no, wait. Oh wait, oh wait, what the fuck? What is this? What are they doing? Are they like creating a struct before sending it? Ah, so that means in the Vulkan.
Yeah. So that means they're only taking one argument, but like the argument is struct with like all the information.
Yeah. Let me just... Yeah, so then that's why they take in this thing, and then this thing contains presumably all of the information. Can I go to the struct? Where is this struct? Wait, but that's buffer. Yeah, that's not VK buffer create info. So where is this thing created? I would assume it's in the main graphics API, so all of them can use. Yeah, here. So you can have vertex index uniform, and then it's just this information, and then in here they Vulkan
Yeah,
create
just create a
info.
Vulkan buffer.
Does that one have the same layout? Or how can they just give it straight into it? That doesn't make sense. Oh wait, this is VK. Okay, I was like, what the fuck am I reading? Okay, no, I'm tripping. Okay, and then size. So they create the Vulkan create info, and then here type. Okay. So here they just specify which type of buffer it is. This is quite nice and generic. I like it, to be honest. I might yoink this idea. And then they create buffer, and then they get the yes. Oh my god, this is so. Oh my god, this is. Let's yoink this idea. This is amazing. I love it. Except for this part. This got me confused. What?
I think I actually also have in my C thing with Vulkan, I have a create buffer. Yeah.
I'm just wait, but then so you pass in the size, you pass in the type, you pass in the data. What the heck is this? Oh, you actually I have no idea but I guess if you yoink that, it will be easy to understand. But this is a really nice thing. I think this is amazing. This amazing. But this is a Vulkan crate buffer, right? It's not a XR crate buffer. Just need to clarify that because I don't know. Sometimes it feels it's. So then I'm just thinking where I will put it. I'm thinking I will put it probably in the Vulkan file. You don't really need. This is not swap chain specific, right? The buffers. Are they? No. No, they are not, because you also need them in. Yeah, I will yoink this idea. I like this one. Because it's basic.
If you want, I can also send you my one.
Sure, you can send it. We can. What happened? I don't remember pasting the. Oh, this is not mine. Okay. I was like, this ain't mine. Yeah, no, it's not yours. I was like, I don't remember this. I think I will put it at the bottom. Like so. And then this will just be create buffer. Yeah, we'll just call it create buffer. And then I will just pub fun. So lots of pub funs. Oops. I always press control for some funny reason, bruh. And should I also make a own struct out of this? I think I will return a specific pointer, but for now I'll just say void. It will complain later on, but yeah, we'll also take that specific struct that they had. So you just pass it straight in there and boom, we're all happy. Yank that. Well, actually, we could also have.
Okay, send you mine.
Actually, this is kind of why even create a struct for this whole thing? Why not as in the parameters directly?
Mm,
I mean,
I'm not sure. Maybe.
this is the only thing I could think of that you would only like to have these types, right? But otherwise, you're always gonna be passing this anyways. Why create the struct just to destroy it or like reopen it later on in the function? I think that sounds kind of stupid. Or am I missing something? Maybe I'm missing some. Probably I'm missing something. Let's see. Because they do it here, they have this. They store the buffers. But this could literally, yeah, that's what they do.
Yeah, I think it's good.
They literally just
Not. Yeah, that's. I don't know where I make a structure of that.
Yeah, they are literally just doing it here once so they can create it and then reopen it later. Is it being used maybe here as well? No, it's literally only in these two places and then it's done. That's interesting. Well, I guess I will not be doing that. I will just take in the parameters as they are. Yeah. Which is, first of all, will be the type. What the fuck happened? What was that, bro?
Maybe it's getting kind of like, I don't know, sounds weird because of my noise reduction.
Yeah, it sounded like, I don't know, like you choked on a table leg or something like that.
Yo, I just watched in your stream.
You watched my stream?
It's so funny.
What happened on my stream?
I watched it playback in the stream. No, like how it sounded for you.
Ah!
No, no, but it's like, it just cuts out from the part you make. That's actually insane.
Yeah, I know, I was like, okay. T-Chef is going crazy. What is this? Is this a U32 bit flag? I think it is.
What do you mean?
Like
the vertex buffer or
yeah,
vertex buffer bit.
it's
yeah, probably.
it's a seint. But I guess you could do a U32 as a parameter and it will still understand it. The only thing I'm thinking, like, is there a better way to write it? Like, should one make like type checks and see like what it is? Well, I guess you could make a check inside of the function every time you call create buffer and see that are you creating something valid or are you creating some bullshit right now? Basically. I think that would be the way to go.
It's a UN32 T flags.
Yeah, for you in C, but for me it's just a C. But what would say just U32? So I will say type.
Yeah.
Or I will just say buff type.
It's defined as a UN32T.
U32, and then we will have a size, which is a U32 as well. No, that was a U size, I think. I will just do U32 for now. And then they had, what was the other one? Stride. Where would you use stride? Bruh.
You know what stride is?
Is it offset? No, why would you? Nah, I don't know.
Yeah, it is the offset.
Huh.
Like, yeah, it's the offset between it's the offset between the like elements of a thing.
Wait. Yeah, wait. Why not just call it offset then? Why make it something like this?
Nah, stride. I think stride is like it's a convention to call it like that. I'm not sure what stride means. Like,
But it's not even
but
used.
I've seen in OpenGL also. It's also called like that.
Wait, but is it like where would you pass it?
You would use it, for example, if you have not in like when you have like also like texture coordinates and like normals in the same buffer with like the vertices,
Mm?
because then the stride would be like something different than your vertice count, and you need to adjust to it, so that it knows.
Yeah, so it's when you have the different data like alignment. Is it that?
Yeah,
Yeah.
like it's not memory alignment, but yeah, that is like
So when you have because you could have literally just a single float, but then directions are 3 floats, and then you can have also 4 floats or something like that, and all of those have different kinds of spacing. Space. This one for now will just be a void pointer. I don't know, I think it will Sig will definitely not like that, but for the time being I will accept it.
any opaque.
Yeah, I'm not gonna use that. I'm gonna see what else I can do. I try to avoid using any opaque.
Any pointer.
Any pointer. None. Any sig.
Is there something like any pointer?
Well, that's basically any opaque.
Okay. So any opaque is a pointer.
Yeah, if you make it a point. Any opaque, it's basically meaning that it can be anything. It's like the void. Sig any
Okay.
opaque there.
Wait, any isn't the type, right? Any is like only like for printing stuff, or can you say any as a type?
Let's see here. Known size, which means that it cannot be any opaque or any opaque type. Void is distinct from any opaque. Void has known size of 0 bytes. Any opaque has unknown but non-zero size. What? But huh? That's not really help. To interpret with C void type, use. Okay, so yeah, if you wanna do C void type, then use any opaque. Fuck, I might actually have to use this. It's okay. Not really. What am I trying to do? It's yeah, okay. So this one is just buffer. So it would be var c buffer and like so. Can I tell it to be 0 like that? Is that okay? I hope it's so. Yeah, I think it's okay. Then we will say var this one colon c dot this is equal to dot this. Oh no, I forgot that. Woo. And then we'll take all of this. Go here, do that. Do this, take that away, go to the end, do that. And then we'll do this to see that type. Remove the null there, leave that like this. We cannot do a static cast here, but I think we can just pass it in like the why would you whatever. It's just gonna be the size. And then that this could also be a parameter passed in, but And this will literally just be pipe type. We could, oh fuck, do this. Now I'm always saying that it's gonna be a usage transfer, which might be a bad idea. Which is actually usage type, I would say. Usage. And then I will probably add a control check of this in a bit. So this is the buffer. When buffer create info, I will just, I prefer to call them buffer create info. And then here we take in device. Well, now we don't have access to the device. How do they have access to the device?
Can't you just pass in like the device?
Yeah, I guess I could do that. I'm just curious to
Like,
see also.
or I'm doing it in the C example, like in the C thing as
oh
like,
yeah, did you send it right there?
Yeah, but I'm not sure if it's even like I think it's like only the half because I kinda split it into two functions.
Yeah.
And that's like only the function that like creates a VK buffer, but not like fills it in, you know?
Yeah.
But yeah.
No, that's okay. I see what you have done. What have you done? Okay. I mean,
Here I just pass in the Vulkan context, and the Vulkan context has like all important things.
yeah. It's almost like would like to have a because now I need to keep track of these buffers, so it would be nice to have something that meant.
But don't you have it in the engine struct?
I don't. Yeah, I guess I will put it there. Yeah. I can do that. Well, I will probably split all of these up like a bit more modular, but let's see. I guess we can go for that and just I guess it would make sense to actually just make this whole thing a member of the engine, right? Because you don't really create this buffer outside of the engine, right? Or well, and then you could just say self device here, and it would just
creating the buffer should like could be part of the engine. Yeah.
And then would still return it, but yeah. I will see. I will for now just pass it in as a parameter, and then the one who calls it will call destroy this thing when they're done. But
like I will see how we did it before that, you know, like that we have a thing. Because I'm not sure if we returned it or like pass in like a VK buffer, which again like gets filled by it, you know.
No, I will return. Well, yeah, depending. I think I will return the actual like buffer. Oh wait, but you have to. No. Ah, yeah, because you have to do this. But yeah, the buffer is the only thing that is relevant to all of this.
I think you messed up the parameter, the function parameter.
Oops.
You did C style function parameter.
Yeah, I'm still used to the C style, bro. I'm trying. Okay, so then we will have device, and then here we will have the memory requirements, which will be a var. See that, not the other way around. I suck at this, bro. Alright. I don't need to do this actually. Undefined, like so. But if this mem zeroes it, why do I say it equal to undefined, can I not just say equal to 0? Isn't that better? Because if I say undefined, wouldn't that mean that it's... And then here we have the memory. It will also be var. Why would you call... Okay. Is equal to dot this.
But wait, you're returning the buffer now, right?
Not yet, but I'm thinking like I probably will return it.
Because if you return, you see, for example, how I did in the C example, like I'm not returning the like VK buffer, but like a custom struct that has like the VK buffer and
Yeah, I noticed that you're...
the device memory.
Yeah, I think I probably will have to do something similar to that actually, because you need to destroy both of them. So
Yeah, so it's quite good to have them.
I will return both the buffer
together.
and the device memory. Yeah. This also will be a var. Allocate info. And then we'll take that, and it'll be this. And then... What the hell? This will also be a var. Yeah, because we'll take that. See this equals that. And then see that get this. But now it doesn't know what... Fuck, it needs both physical and logical device. And now I'm starting to be like, should it probably just be inside of the engine? I will just do physical device. Physical underscore device. C VK physical device. And then, oops, I'm not seeing the chat. If somebody's saying, no, nobody's saying anything. Physical device here. Like so. And then memory type from properties. So they have a function to do this as well. Okay. But does that have to be a function? Couldn't you literally just do this? Yeah, what do you do? Because then you can just see what if it, but you could also just and I need to modify that one slightly. Oh shit, I need a different one depending on this case also. Damn. Well, we can I can still modify the code, it's fine. But I don't think this needs to be a function call inside of here. I think they could, well, unless if you're gonna use it in multiple places, but bruh, I swear I did yank it. Well, I will just do this. And again, I do the wrong thing. Like so. And then here, This is an interesting way. So C to this. And then you capture I. Oh no. Okay. And then type bits. What? It's a parameter, alright. It's the second param. So memory requiring memory bits. Are my eyes deceiving me? A for loop C style in SIG code. Hello. Yes, I am. I'm a bit too hard of a fan of C. I have written this loop another time and it was even more C style back then. And even though I tried to do SIG, but I can't. But now memory type bits. Why would you? Yeah, you check this, and then if type bits, type flag, type index. Yeah, okay. What's today's task? Today's task is to get cuboids. I think I put it in the title as well. To get cuboids.
What even is cuboid?
What?
What is cuboid?
I think it's literally, I don't know. I think it's literally just cubes, but they have volume. Cuboids. I think it's cubes, but you can size them. Oh, wait. Okay. There are cubes. That's what all you need to know. Nothing else you need to know. There are cubes. So you get all of them, then you go through, then you say type is available, does not. Then you take mem type, and you check the property flag and required bit mask. Then you return that. Yeah. So you get all of the property or the mem type bits, and then you check is that bit also what the user asked for. Then if it is, we can use that. Yeah. But, whoa, crazy. All of those could actually be parameters of what you want, and then we could use it in multiple places instead. But I don't see really a use case yet for that, so I'm not gonna try to do it like that. I'm just gonna straight up do it like this, but Well, I don't have a straight up use case for it, but when I get to it, then I will do it. I didn't even know this one existed. I've never used that one before. Have I? I don't think I have. Just gonna do this. Bruh. Okay. But they're a bit shifting the actual thing. Quite interesting, but yeah, you don't really need this anywhere afterwards.
A bit shifting?
Yeah. But I don't know, can you do this in Sig? I don't think Sig likes this. Yeah, I'm pretty sure Sig doesn't like this.
Wait, be right back. I'm gonna switch to Windows real quick to play a few games of Minecraft.
Alright, hardcore. Hi,
Yeah,
it's
I'm
me,
playing
Cheesecake,
sweating
winner
again.
number 1. Oh, wait, what did you say?
I'm sweating in like bad wars.
Ah, okay.
Whatever there. I'll be right back.
Alright, see you in a bit. I will just rename this to be like this. Then it's also clearer to read. Type it is equal to memory requirements dot memory bits. Am I stupid? Type bits. It just doesn't find it. It's probably there. And yeah, U32. And then bit shift right, and then you go another round. And then for type underscore index. And maybe you don't even need to do these ones like this, but damn it. Okay, never mind. We cannot do it like this. We will just have to say that allocate info memory type index is equal to I. And then we can remove that. Also gonna tell that to be null, just realized. Let's see. And let's see if this is equal, and then it doesn't know really what this is, so well, we are asking for these two. Property host coherent. Okay. Const desired bit flags. probably could take this in as parameters as well, so you could change what you want, but right now I don't see or required, but so, and this is probably not gonna be fine, but it's gonna be fine. Loader, VK.
It's gonna be fine.
It's gonna be fine. Your voice is a lot more crisp now.
Yeah, I'm on Windows.
Yeah. Crazy motherfucker.
It's actually insane. I played better on Arch than on Windows. Oh, I didn't got that power anymore. That Arch buff.
It's all about that arch, dog. It gives you hidden powers.
Yeah.
Why can I not? I will do it manually then. But this thing I'm a bit set. What the? Oh, so this is the now you call the actual. Let me just confirm that. What the fuck do they do? Set buffer. VK device uses heap with properties to host. We don't need to use VK flash map ranges or. Never used it without that, so that's also interesting. But I don't think this needs a separate call. Well, maybe if you want to split it up and do it manually sometime, but for now, I don't need that.
I have it in 2 functions.
You have it in 2 function. Why?
Yeah, but I don't know. I think because actually this data to buffer can differ like on old cards with the memory. You know, I have it like I've been following the tutorial for that, so it's not like I invented it, but with the memory of graphics card, like some of them have like really small amounts of memory that can like, you know, with a host visible bit and stuff that you can set. So there's a method with like staging buffers, which is like a little bit more complicated. And then you basically can get it into the like VRAM of the actual device.
Yeah.
For like older GPUs, you can do that. So that makes like the upload, like the data buffer thing a little bit more complicated. So that's why it's split up.
But wait, so you have like. So the only thing you do separate is the VK map memory then, but isn't it?
Yeah.
But isn't wait? Huh?
It's probably like it's not really a thing you need to do probably.
Yeah, no.
But yeah.
I just okay. Bruh, I did this wrong. It's okay. Damn, KK is always flashing its what's it called? Like the chat is always flashing at me. It's like updating weirdly. It's like Yeah. I just wanted you to know.
Yeah.
And then Wait, what? How do they do? I still don't get why they do this. They have a buffer, create buffer. Oh, buffer resources. Oh wait, so they are. What is this thing anyway? I have no idea. Okay. So they keep track of those things. Okay. Oh fuck, I was supposed to keep that one open. No! Oh, okay. So, oh, okay, now I see. So then you... And then you take this and you keep track of them over here, and then here you ask for this one, then you get that one, and then you free and you destroy. Ah. Okay, so that's how they keep track of these things. Yeah, I will probably just why would you... That doesn't make sense. I understand the memory thing. Oh wait, you get... But that's not it, they are passing this thing. Ah, okay, so that's what they're doing. No, the memory is this thing. It shouldn't... Oh yeah, it should be that. Okay. Now I'm starting to see it. It's like, okay, what? So for me, that is the data. Wait. And then the memory. Which shouldn't be the... Is it really that? Well, we'll see. I will not do that though. I will return it and we'll leave it up to the person who uses it. We will have access to the VK buffer still, so we don't need to do this, and we have access to memory. Map data. Oops. Var that. Loader VK check. And then we'll take this. Don't need that. Actually don't need those either. And then if I never do this check actually. But I guess we can do that. Return buffer. Stupid fly. Shouldn't it actually be this? I'm feeling it should be that thing and not this thing they're actually passing in. Yeah. I think they're doing something weird there, but oh, freeze. Okay. And then we just created it. Yeah. See that this null. This probably needs a try. So unclear identifier. Create info. Yeah. Buffer. Create info. See that. And this can go away. Can it not? Should be. Yeah. Oh wait, did I? No. Okay, it's something else that is problematic. Use unclear identifier memory properties. I've actually made such a horrible typo. Actually, I have. What is the properties requirements? Oh, wait, hold on. It's just a different name for the same thing, isn't it? Oh, shit. Okay, I'm tripping. What? I forgot my key bindings. Ah. No? I actually forgot my key bindings. Oh my god, what? I'm having, okay, whatever. Doesn't matter. That's incorrect. Amazing. But for fuck's sake. Oh no, but it's not even that much, the clock. Wait. Okay, now I remember my key bindings, bruh. I property flags. Yeah. Don't care about that. Can actually remove it. That. Oh, what the hell? I undid everything over here. Oh, yay. It's okay. How's the VR project going? Developed from scratch. It's good, it's good. We are gonna make some 3D stuff now. So, yeah. Let's see how it goes. That's the goal. There is no mem copy though. 3D or 2.5D? It's gonna be 3D. I'm not doing like ray casting. I'm not gonna do that.
Like it was 3D before that also, like with
Well, I guess it was 3D. Yeah.
motion.
Yeah. But we're gonna make some actually. It's just not gonna be a flat triangle. Well, it's a 3D triangle, but still. Yeah. Add mem copy. How do one do this correctly now? Because now I got. From where to end, right? And then from where to end. Let's literally this thing. So it's data, from start to size. And then I want to take, oops, it's the other way around. Map data from start to size from data. Like so. Oh my god, how much did I undo by accident? Oops, null. Use that as a reminder. Requirement mask, yeah, that's true. That should not be that. That should be desired bit flags. Don't I have a crate? Yeah. I was like, I was pretty sure I had it. It's okay. No pointer. And this one. That. And is this now the thing that we call up here? That I don't pass in, probably. Let's see, because we pass in buffer. Oh, but we pass in 0 here as parameter, so yeah, I can just put 0. I will always assume that. And then see that. We'll get back to this in a bit. So we just create the index and then the uniform buffers for, what is this second one? Oh, so then you create the camera through that one. But yeah, I keep the camera in a different kind of way already coded. But how do they do the camera anyways? Do they have a... okay. And then they manipulate that. Camera constants, yeah, okay. Yeah, I will not do that, but I will do this and maybe also try to take a hit on those normals. Hello, Code Fox. No. Because they will not be within there anyways later on. I will just call them const, and then index buffer, vertex buffer. For now, then we can later move it out from here once we know that how everything is set up. And this will come from vk create buffer. vk.create buffer. And what we'll take in will be cvk vk, no, bruh, no, it's c vk text. What is it called? Hello world. Hello Eldin. Ah, I don't know. I'm adding some extra things to your name there. Tetrodoxins is I can't pronounce your name either, even though you have joined like multiple times. Yeah, I wanted to check still, like they do. Here to see because buffer usage, yeah, buffer usage, that was this. Buffer usage, buffer bit, and then, well, size offload. Does that work? Is this okay? We'll see if this is F32 or it's U32. Why you use that? I think we should use... Okay, but for indices that makes sense, but for these ones they are F32s, yes. There's still no Emacs situation going on. No. No. You know, actually now I think about it, I need to do this inside of the engine. Fuck.
Which function now inside the engine?
I need access to the logical device and whatnot, so yeah, I need to do it after I've created basically all of this, so I guess we will have to do it here, but we will move it out once we get further into this. But for now, just to see that we get that rendering correctly, so I will just say to do move out. But that cube situation going on. Yeah, we are trying to make cuboids. Woo! So now if I do VK, create buffer, yeah, now it tells me all of these things that I actually want to know. I want to know, so we want to pass in physical device. Should be called physical. Why is it not pop? Why I want it so because physical device device, and then we have
device.
What?
There are more devices in Vulkan than I don't know. There's millions of them.
Yeah, that's so crazy. That how comfortable are you with Vulkan by now? Not at all. I'm still learning Vulkan.
Like, oh, that's so much.
Yeah, there is so much. Usage vertex like so. But it's okay. I probably need to how do they do it? They had this thing, but I never saw them using. Oh damn, this is awful to read. Type. Then they used. For some reason they store this in here, which I don't understand why they would do that. But okay. And then they continue to do this, and then at some point, oh, it's buffer resources. Yeah, I want to continue checking. Let's see, destroy here. Take first. Offset. That's the second parameter passed in. 0. So then we use that thing, which is, I found it super confusing. So I'm not gonna use it either. I'm just gonna say how many of these we have. And then, wait, this is the vertex, bruh. Why is it not popping up? Cube, vertex positions, yeah. Indices. I'm gonna call it also cube positions. It's easier. Well, maybe vertices, bruh, if I call it indices. Vertices. Like so. Probably need to do a try actually on this thing, I just realized. It's okay. And then Vulkan create. I'm actually just gonna do this. And then I'm just gonna, same parameters, the only difference is this is gonna be VK buffer usage, and then it's the index buffer bit, and then we do, oh whoa, hold on, what the fuck, Did I actually remove that? Cube indices, yeah, and then the data. Like so. And of course I did it the wrong way. This one is supposed to be vertices. Oh no, the vertices. What did I do indices on the second one? Cube vertices. So this one is the indices. Yeah. Cube indices dot len, and we don't want the ampersand there. Cube indices ampersand, and then we will get these ones, and we should store them in. Well, for now we'll just. They will not change. I will just call them const vertex buffer that, and then const, and I'm gonna call it index buffer. That one can be dealt with later, and then in the engine this is gonna be moved out as well, but for now I'll just do move out, and we will just say same, just index buffer, and let's say f32. But now I don't know. Actually, no. What does this thing return? It returns a void pointer. Okay, we'll see. Maybe Sig will allow it. And then yank that, paste that, and then vertex buffer. Should maybe specify that I'm talking about the, well, this is for the camera buffer. Well, I guess I will not do it, because I already got the camera in another place, which I probably will move because of this now. But nah, I think yeah, we will move it, but not now. First, I will just do this, and then I will see how, because they will still combine in the same spot. Or should they? We'll see what I will cook up. Const, and then normal buffer, and maybe like that, paste that, cut that. I did not cut it. Cut it, paste it. That's not how you paste it, that's how you, bruh. Buffer p normal, yes, it's not a pointer. And then here it's the same thing all over again, but the difference is usage will be uniform buffer bit, and then just normals here in this one. I think I just call it normals. Yeah. Like so. And then we don't need that, and now of course all of these ones will be like, what the fuck? So we will do a dot, and then none of the buffers shows up. Index buffer is equal to buffer, and then norm. I don't have the normal buffer. Like so. Yeah, if I can reuse this also for the camera and then for the in another spot, it will probably cut this
Well, it will probably take away like 200 lines of code from the main file, which would be nice.
Because how long is this one? It's from 421. Okay, 50. So it will take away 100 lines if I did it, which would be pretty nice. But yeah, they shouldn't still do anything. Like if I start that, I should get through the application with just starting this. And then they create shaders. I already do shaders. Then they create the graphics pipeline, which I don't think there's anything special with this. Oh wait, there might be one thing that I need to consider actually. Yes. Or the pipeline, not the graphics. I always say graphics because I always read this thing. Why is there a fly on my screen? Bye bye. Pipeline create info. So create pipeline. Oh, that's destroy. Wait, they create pipeline there. I still think I have some bad like intelligence because I don't see these structs clear.
My new intelligence is crazy.
What have you done?
Yeah.
No,
I'm
but
just using tree sitter.
I'm using the what's it called, the Visual Studio Code still. So yeah, I need the what's it called? When you hover around function, you can see their definition, and then that when you control click, you jump to them, and then that. There was the third thing. Then I would switch over to NeoVim completely, but well, nah, I don't know. The debugger is still quite nice in Visual Studio Code, to be honest. Like this.
But there's 3DB.
Yeah, but it's just visually
There's
appealing.
3DB.
You know, it's visually appealing. You don't get it. You don't get it. Okay. Why is my Visual Studio Code freezing, bruh? I'm leaking so much memory, you know, that's why.
Don't leak your memory, guys.
Yeah, don't leak your memory. Oh yeah, because this is their own custom shit. Damn. Why do they always have to have some custom? But yeah, it's. I'm gonna assume it's this same one. What do they have? They have vertex state attributes. Back 4. Text core. Oh no, they're passing in some. What is? Yeah, that's their own thing again. Shit. Oh no. Okay. Well, I guess I will have to find out on my own then. Let's see. But I have now. Yeah, but that I have added. Let's see. I want to actually see this. Over here, depth stencil. Yeah, everything should be fine. But here. See, swap chain, depth here, color format, and then depth format. That I also need to update for mine, not mine. if I would remember what subchain format. The buffer. They also seem to have some builder for the buffer. Damn. This is crazy what they're doing. Layout, pipeline, layout. So I have probably device, layout, create info. And what do I say here? Don't really set layout, count 1, and then the descriptor set layout. Yeah, shit. I will be needing a little bit more now. Because we will have this one. Yeah. Here. And let's see, what does it... It creates only the uniform buffer, but now we also need for the... we need it for the what's it called? The... vertex and uniform, yeah. Type, if I do this, should pop up vertex, or am I... Are they all uniform? Oh wait, they're vertex bit. Yeah, and then... I don't remember actually this shit. But there should be different for different purposes, right? Or am I completely tripping? The top is defined by an array of zeros or more descriptor bindings. Each individual descriptor binding is specified by the description type, count, array size of the number of descriptors in the shader stages that can access the binding, and if using immutable. It's fine. There wasn't really much. Maybe this one will tell a bit more. What did you just say, buffer? Stage. No, there's stage. Yeah. Because there is... I assume you would pass... Oh, vertex fragment. But what is... Wait a minute. Don't we create... How does the fragment... Now I'm a bit confused. It's okay. I will figure this out.
What's the question?
I'm trying to think through now. So we created these buffers, right? For the indices and the vertices, and then we created some normals, right?
Yeah.
So now we're getting to the pipeline. Maybe it's just because they're using their own like kind of helper function utilities that's confusing me. I'm not sure. I don't think it is. That's why. But they create their pipeline, right?
Yeah.
And then here they have like structs, presumably, that they're just passing in where things just works then. But then they pass in 3 layouts, and I'm wondering, why do they pass in 2 vertex and 1 fragment? We just do 1 vertex. Hello?
Yeah, I'm not sure.
Yeah.
Wait.
Maybe I should
Wait, they have three layouts. Maybe do they have other data also in the vertices, like in the
Well,
vertice array?
because
Like maybe one
my
for
triangle
normal.
is not, my triangle is in the fucking shader hardcode, and that's why I only have 1 vertex layout, because I only need 1. Wait, but why would they need 2? But what the fuck? Now I'm getting really confused. Wait, what? What?
Wait, a layout is just like for the data in the vertex shader, right?
Yeah. And then another thing is they have also the fragment, right? But we don't have fragment. But we don't pass any data to the fragment. We take all of the data from the vertex to the fragment. Yeah. Now we're gonna need, if you're gonna start using normals, we need to have that passed with it. But
Yeah.
okay, I need to see like how does their thing work. Because but they're creating 2. Maybe that's why they're creating. But why would you have? They're creating 2 cuboids. But why would you create 2 separate? Why could you not just? Couldn't you just? How did I do it with my Minecraft flow? I don't think I created a separate layout for every single chunk. That would be crazy.
No, that's not necessary.
Yeah, I think that's just overkill what they're doing right now. Let's see, where's the Minecraft clone? There. Stupid flag, go away. I'm trying to look at the screen. Oh yeah, now to look at this horrifying thing. Oh, it's not that bad. It's a lot more pleasant than I remember, actually. It was for the cube map, maybe? Yeah. Let's see. Here. So I had for the sky and then the UI, and yeah, here I have for the actual. This was what I used for all of the chunks rendering. So add binding 0. Oh, wait. And then I just took in uniform buffer, shader, stage, vertex, and fragment bit. And then I had combined sampler, shade, stage, fragment bit. I don't remember what was this for. But this builder was really cool. I remember it. Info. Layout. Read only optimal. Texture, and then I got texture, and then sampler. Okay. Right buffer, right image, build. Yeah, and this was the builder there. But yeah, I didn't create, then I just reused that throughout the whole thing.
I don't really know how that works.
Yeah. I'm just reading at all code, trying to connect the dots. It was actually a pretty good setup that I had. I didn't remember it being this. Like, I remember it being way worse than this, but this is not that bad. Huh. But yeah, it's this one which I'm interested in. So, can I get to... here? Okay, that's fine. Let's see, what do they do here? They have the... create pipeline, and that's this thing, so they take in this thing and then... Oh, I could actually see here what they do with it. Amazing. So they take the color format, for color format here, they have this one, they push back, and then okay, store, okay, and then they do the reference, and then the depth, and then they do the format. Okay, but I think I had that same here. When, okay, bruh. There should be 2 of these. Right, it's not in here. It should be in here. Yeah. Pretty sure. Yeah, create render pass. Did I undo it? I swear I had it. I'm pretty damn sure I had it. What the fuck? Huh. I don't show it. Okay, interesting. Anyways, then they do what? They have this. And then here, I am supposed to pay attention to this thing, not the other ones. That.
that the only place? Okay, nah. Depth format. Oops. Okay. Here. Private layout and descriptor set layout. So descriptor set layout for each set VK descriptor set type. Then that, and then here it is. And the shaders, vertex input here. Now, let's see. Vertex input binding. Assembly tessellation, viewport, restoration, and multi-sample depth sense. Jesus Christ, what is that? Damn, no, way more over here. Wait, do they have? Oh, so they have a hash map of all of the pipe. Damn, that's smart. So you can just create whenever you want one and store it and then reuse it. Or reuse it, easily access it. My bad, not reuse it. And then you just go through the whole map and free everything. Whoa, my mind is actually like, whoa, I need to read more.
You see that meme from that one guy with like preparing for a coding interview, and then like with a hash map.
Wait, Nim, who, what did you say?
That meme. That meme from on YouTube, just search preparing for a coding interview. With a hash map, this is.
Okay, wait. Preparing for coding. Kidding. Interview hash map.
Nah, that's fine. I think it's probably just maybe. Yeah, then yeah, I think that's the first one. Yeah.
First one.
Here's how I prepare for my coding interview. I solve 1,513 LeetCode problems, memorize all of the answers, read Cracking the Coding interview 5 times, read elements of programming interviews in all 3 languages, Python, C++, and Spanish, mapa hash puta madre. Read Grokking the Systems Design interview. Don't understand shit, but memorize every keyword, sharding, caching, load balancing. Damn, I'm so smart. Go on LinkedIn to stalk my interviewer, check their Facebook, check their Twitter, check their wife. Nice. Go on Glassdoor to find the interview questions they ask. Not good enough. Pay lots of money to access a sketchy Chinese website to get leaked interview questions. Perfect. I go to the bathroom for my breathing exercise. Fucking love meditating. The company is calling me for an interview. I bring up all my cheat sheets. This is child's play. I'm ready for this.
Hey, thanks so much for hopping on this call.
You're welcome.
Yeah, okay. So I'm your interviewer, and yeah, so the first question is, what would you do if you had a conflict with your manager?
Hash map. I'll use a hash map.
Damn, what a great answer.
Yeah. Hash map. Why no linked list? Doubly linked list.
Why no
Why
linked
not?
list? Oh no. Yeah, I don't know.
Hash map.
I should try implementing my own hash map at some point, just for the funsy. just to figure out how they actually work. I just know they're efficient, but I truly like. If you told me to implement one, I would be like,
But there are so many random data structures that like fit well for like specific things.
Yeah.
Yeah.
Then you got the beautiful, you know, what are they called? Object oriented paradigms. Let's see. I think it's, let's see, there's a beautiful page that shows all of them. I can't find it. It's not important. Or design patterns. Patterns. Design patterns. Yeah, this one. Like, I don't know, like all of the there should be a list showing all of them. Here. It's crazy. Like, I was thinking, well, should I just try to learn all of this, but then it's also like, I'm actually just trying to move away from object-oriented programming like as a whole, so I don't know, like, if I even want to learn all of them, or any of them. They're probably good, like the builder, for example, is really nice, I like it, but it's also like, I don't know. A command I have also used an observer is really useful. Factory. Wait, abstract factory, is it just factory? I don't know what it's called. Factory is also something that singleton. The best. Yeah. I haven't used or created the other ones really. Prototype, maybe, if I remember correctly. Strategy as well, maybe I have tried. But, yeah. Still trying to think, like, should I change this so we could actually use the attachment of the... I need to figure out, like, what is actually now, because I'm feeling lost regarding attachment, descriptor pools, and layouts. I know kind of what they all have to do, but I'm like, I need something stronger to reinforce it actually, because I'm like, just reading it and be like,
Maybe look into the Vulkan tutorial or into the specification.
They usually explain stuff really, really good in it. Let's see. Maybe even start from the buffers just to get the clear, like, because then it would build up, so I would refresh memory on it. Approach of creating CPU visible buffer and use memcopy to copy the vertex data into the... What the fuck was that? Oh yeah. And after that we'll see how to use staging buffer to copy the vertex data to a high performance memory. First, change the vertex shader to no longer include the vertices data in the shader code itself. The vertex shader takes the input and a vertex buffer using in keyword. Right, and that's why we don't need one, because, but yeah, now we'll change stuff, so now we will need it. The in position and in color variables are vertex attributes. They are properties that are specified per vertex in the vertex buffer, just like a manual specified a position and color per vertex using the two arrays. Make sure to recompile the vertex shader. But why would you take in color to a... I was thinking, why would you take in color to a vertex shader? But yeah, you can pass it on to the fragment shader. That's why. Just like frag color, the layout location X annotates assign indices to the inputs that we can later to use to reference them in them. It is important to know that some types like dvec3 64-bit vector uses multiple slots. That means that the index after it must be at least 2 higher. Okay, is that with memory alignment or wait, 2 higher? Or what does it be? At least 2 higher. Okay, yeah.
Okay, I gotta eat real quick. Be right back.
All right. You can find more about the layout qualifiers in OpenGL Wiki. Vertex data. We are moving the vertex data from the shader code to an array in the code of our program. Start by including a GL library which provides which linear algebra related types like vectors and matrices. We are going to use these types to specify the position and color vertex. Create a new structure called vertex, kind of what we have done. The 2 attributes that we are going to use is the vertex shaders inside pos and color. GL community provides us with C++ types that exactly match the vector type used in the shader language. So did they give the color, and then now use the vertex structure to specify an array vertex data. We're using exactly the same position and color values as before. They're combined into one array of vertices. You can even browse the web in Emacs, although you shouldn't. I am. Yeah, I wouldn't. That's crazy. Now they're combined into one array of vertices. This is known as vertex attribute. Yeah. Binding descriptions. Now this is the part. The next step is to tell Vulkan how to pass data format to the vertex shader once it's been uploaded into the GPU memory. Once it has been uploaded to GPU. What? There are 2 types of structures needed to convey this information. You can even get a therapy session in Emacs. You should. Just because I'm trying to understand Vulkan. The first structure is VK vertex input binding descriptor. We will add member function to the. This was not a joke. Google it. You can get the. Hello, Doggo Man. We love the universe and everything. Oh, it's Hitchhiker's Guide Through the Galaxy. It's all getting too much. Emacs has Dr. L to help. Consult the doctor type. Exam doctor.
Wait,
that doctor is.
Hear me?
Yeah. Oh, it's Mr. Harold. How are you doing?
Grape.
Grape? You're doing grape. The doctor is Rogerian psychotherapist who will help you with problem. It will spoil the fun and hurt your recovery to say too much here about the doctor, how the doctor works. But when you're ready, find to see Wikipedia. Okay. Sorry. Back to Vulkan. Harold, you still here?
Huh?
Yeah, you're still here. Great.
Yeah.
Great. How confident are you about descriptor pools and layouts?
Me?
Yeah.
Like out of 10, like 4.
Okay. No, I'm just.
Maybe
I'm trying to add the vertex buffers now and the indices and this. Oh, I don't even add the textures yet. I will get to it. But, okay. Get binding descriptor. So binding is just to set up where these, how they will bind, right? So you tell it that it will start from the main and these stuff. When you connect the data to the shaders. And we'll add memory function vertex struct to populate it with right data. Okay, so they just have this. A vertex binding describes at which rate to load data from memory through the vertices. It's based so the numbers of bytes between data entries and whether to move to the next data entry after the vertex or after each instance. Oh look, but there they have the. Yeah, there they have the stride, but I don't create the vertex thing here.
But like what you see what you're really doing is you're just getting like a pointer to the memory with the binding, and then you like set that with pointer arithmetic. There's nothing more to it, like the descriptor is just like information for Vulkan. Like what the hell are you even doing here?
Isn't descriptors how you're supposed to manage the memory or the shaders and the vertices that you pass over?
That's possibly a part of it also. I'm not too sure with Vulkan, but in like SCL, that's how it is.
Ah. Okay.
I'm pretty sure.
Yeah. Vertex binding describes at which rate. Yeah. So I read this, and then you would have that, and then you return. Yeah, because they have size of this, so that's per vertex information. So per vertex will get this information, and that's what the stride is. Ah, and yeah, then binding 0 is. Let me think now. This is associated with the in here, but how do you say the in color? You have the in position, but shouldn't you also have bind 1 for. I'm a bit confused. All of our per vertex data is packed together in one array, so we're only going to have one binding. The binding parameter specifies that index of the binding in the array binding, but the binding parameter specifies the index of the binding in the array of bindings. Ah, okay. Why I'm boring you with this so much is because I hate Visual Studio Code, I hate Microsoft, I hate Electron, so I feel induced to vomit frequently. Alright. Yeah, no,
have you still not switched to NeoVim?
What?
Have you still not switched to NeoVim?
No, because there are a few features that I can't get in NeoVim that I would or maybe I can get it. I haven't done the research to find that, so that's why I'm still using Visual Studio Code. It's more convenient at the moment.
Well, everyone knows it's the superior. So
The what?
like VS Code is the superior code editor for now. It ain't good, but it's true.
It is alright. You know, you can do stuff in it. Not just a normal text file. That's the way to go. You know, I love just reading coding and textile white and black. You know, that has high of a contrast as it can get.
Yeah, I really like Notepad++.
Oh, Notepad++. That's next level. Okay, so this is the binding parameter specifies the index of the binding in the array of bindings. So when you have multiple ones, it just says that. But I'm still a bit. The stride parameter specifies the number of bytes from one entry to the next, and the input rate parameter can have one of the following: input rate vertex move to the next data entry after each vertex, instance move to the next data entry after each instance. But what's an instance in that case? We're going to use instance rendering, so we'll stick to per. We're not going to use it. Okay, what? Yeah. Oh wait, instance.
Batch rendering.
Yeah, that's what instance is. So you just do batch run, but wouldn't it be kind of that doesn't that only works if they use the exact same like exact same some of the information being exact same. Yeah, but you cannot pass the exact same vertices because then they will have wait, no, you can. Because you still pass, you just pass the model matrix to be different positions, basically. Yeah. You could do that, right? Couldn't you?
Oh.
Which would be kind of... Yeah, because you would have... I'm trying to think. Am I wrong? Like, you can have... But isn't this basically the model? No. What am I saying? You have the vertices. I'm mixing stuff up now. Am I not? Wait. Because this is per vertex. Ugh. But why would you do instance? I'm confused. Like, what is instance then? Like batch rendering, yeah, but like I'm trying to connect like how the data is being used. If you do not do per vertex.
Well, if the instance is like you're giving some shit to the GPU, you're giving it like one thing.
Yeah. But how does that?
So you're basically giving it like one array of like vertices and one of indices, and then you tell it like, hey, this is what I have. Meanwhile, in batch rendering, you give like a bunch of arrays, I think.
Make your own code editor for next projects. Woozy. Probably not. I'm starting to have a lot of game ideas. I would actually like probably do some game jams or something like that. I don't know. I would like to get a few games out, but like not take like a week long time for each one of them, and not more than that. So just to get the prototype of each game idea out, just to try if other people would like it, and then I would continue on that. But that's a later project. Now we're focusing on Volcan. We're not going to use the Okay, I can just literally just instance rendering, but Volcan. Provides the sort of method which allows the GPU to draw multiple instances of the same mesh with different parameters. How do you do different parameters if they all are one common approach is to set the vertex attribute with input rate this, which tells Vulkan to advance the vertex attribute in index on per instance basis. This method involves putting the necessary data such as offset and rotation into the attribute. Another option is to use the built-in GL instance index in the vertex shader, which provides the instance ID. This can be used to instance count greater than 1. For example, setting instance count to 1 will render the same mesh 1,000 times. The vertex shader can then use in the instance to access the appropriate data for each instance, such as the model matrix stored in the additional instance. But I'm still confused. Like, how can you do 1,000 of them, but how can you still change their position if they all use the same instance?
It figures it out.
Bruh, that's the most hateful answer you could have given me. It figures it out. Shut the fuck up. Don't ever tell me that. That's disgusting.
Like you.
Mm-hmm. Just figures it out my ass, Jesus. No, those are the only answers
What is a bad word there?
What? I just don't like it. You know, when you use stuff and it just figures it out. It's like no.
I do like
Attribute descriptors. Second structures that describes how to handle vertex input is VK vertex input attribute vertex input attribute descriptor. So we had the input binding, now we had the input. We're going to add another helper function to the vertex to fill this struct. And that's the thing that I just checked out. So you get attribute descriptions. Okay, that's the function call, and then attribute descriptions. It's input. As the function prototypes indicates, there are going to be two of these structures. An attribute descriptor describes how to extract vertex attributes from a chunk of vertex data originating from a binding description. We have two attributes, position and color, so we need two attribute description structures. And then the binding, because the array was 0, so you put 0 for both of them, right? Do they show the other one? Yes. And then the location, so this is associated with the actual in that you get in the shader here. Yeah, okay, now I'm starting to remember stuff. Yeah. So, but these namings, I don't remember these namings. That's my problem. Well, I have other problems too, but the relevant ones are these namings.
you know what? You are the problem.
I am the solution.
Oh, well, you are the problem and the solution.
Yeah, I'm the Schrödinger answer.
Yes, I agree.
It depends on the circumstances.
Yeah, it depends on the circumstance.
What the fuck, Carol? Not here.
We'll see. Okay, later in bed then.
Oh god. Vertex input binding description. Okay. So yeah, it was that, and then it was the attribute, and then you say the format, yes, and that's just to make sure that it's. Did I read that another prototype indicates that we're two attributes, vertex attributes from a chunk of vertex originating from binding description. We have two attributes, position and color, so we need two attributes description structs. Yes, and then there you just pass the format, and this is a red and green, and then the other one will be red, green, blue, right? Yes. The binding parameters tells Vulkan from which binding the wait, what? Sorry. The binding parameters from Vulkan, which binding the per vertex data comes. The location parameter refers to the location directive of input in the vertex shader. The input in the vertex shader, which location 0 is the position, which has two 32-bit float components. The format parameter describes the type of data for the attribute, but that was a bit confusing. The formats are specified using the same enumeration as color formats. The following shader types and formats are commonly used. Yes. As you can see, you should use format wherever the amount of color channels matches the number of components. In the shader data type, it's allowed to use more channels than number of components in the shader, but they only will be silently discarded. If the number of channels is lower than the number of components, then the BGA component will use default values of color float unit and will be and bit width should also match the type of shader input. See the following examples. 2 component vector of 32 bits. Yeah. Okay. The format parameter implicit defines the type size of attribute data and offset parameter. Specify the number of bytes since the start of the per vertex data to read from. The binding is loading one vertex at a time, and the position attribute pos is at an offset of 0 bytes from the beginning of the struct. This is calculated using the offsets macro. Oh, and then is this pos. Okay.
Yeah, the offset macro is kind of nice. Sorry for any background noise. I'm in the middle of a road, I guess. Yeah.
Ah, why? But why are you in the middle of a road? Isn't that dangerous?
Well, I'm taking I'm on the side of the road, but people
Ah.
going past, you know.
Oh, you trying to get a lift? You're standing there with your thumbs
Yes.
up next to like Mr. Bean. You did.
No, I'm standing with something else up. It's a playing card that's up my
Ah.
sleeve. Like, what did you think of that? Hmm?
I don't want to answer
Yeah,
that.
that's what.
Mm. The color attribute is described in much the same way. Pipeline vertex input. So this thing just binds this first so that the the pipeline basically becomes aware of it, so it's binding it, and then here we tell how they're getting input into the actual shaders, and then pipeline vertex input. Now we need to set up the graphics pipeline to accept vertex data in this form by referring to structures in the create graphics pipeline. Wait, what? Pipeline vertex input. We now need to set up the graphics pipeline to accept vertex data in this format by referring to the structure in the create graphics pipeline. Oh yeah, okay, now I understand. Find the vertex input info struct and modify it to reference two descriptors. So you have the binding, get them, and then attribute, you get them, and then vertex input binding, but the vertex input info component, and then okay, now I see what they do, and then binding. Wait, what is this? What is this struct? Where did this struct come from? Must have been from before. It cannot be this far back. No. Here. So VK vertex input states create info. Okay. So that thing, and then this one is probably, I assume, connected to the render paths. What? No. Shouldn't they be? Yeah, pipeline. Yeah, that makes more sense. And then you pass that in there. So vertex input. But I still don't understand, why would you create two of them?
Bro, I'm trying to eat some nuts, but they are a bit hard.
Crunchy.
No, I mean it's just hard to get to them. There's like a big sack in the way.
Bruh. But these are the layouts, so these are just creating the descriptors, right? And then after the descriptors are created, they probably gonna do Where do we do layout? Oh, that's fantastic. Let's say it. Here. Oh wait. Layout, yeah. Okay. Create the layout. Just gonna see the. I have to probably read all the way to this thing so I can actually get a full understanding of this. But anyways, this thing can be done now in the. I need to do this for the vertices, but I think I have it already there. And I think it's correct. I don't have to do any changes in my create pipeline. So here.
Bro, this hack is so hard.
Here. Input state here. Oh, look at that. I need to do some changes because I don't have them at all in here. For now, I think it's fine if I hard-code it, but I should probably make it more dynamic that you could pass in multiple ones. Yeah, but for now it's fine with one hard-coded. I think it's more fun like this. Okay, I will do this without looking at this tutorial. Let's see if I can do it. I don't know
You're
what
gonna fail in 1 second.
I don't even know what to call this thing. I will call it vertex binding. And it's C.
No. No bad naming over here. Name it Vertex Binding Lucas. No tutorial. Missing help. Yeah, that's a good name.
Bruh, shut up. I got this. It's a create. Maybe I could just say it's a vertex. Oh wait, when it's this thing, it's vertex input. Here it is. Look at this. There is the. I need a binding. Vertex binding. Input binding description. Right? I'm allowed to check that I'm just creating the right struct, okay? Am I?
Yeah, but you also need to create info. Well, not really, but.
Yeah, the vertex input binding description. Easy peasy. And what did they call it? They called it. Oh no, I need to go a bit down. They called it binding description. Vertex binding. Well, I guess mine is fine. Okay. And then in here. Alright, I need to put this like so. And we do dot, and then we have the binding input rate and stride. Binding will be 0 because this is our first.
Bro, these nuts are like they're stuck. I'm getting nut juice everywhere.
What kind of nuts are you eating, bro?
I ain't eating anything. I'm trying to get to them.
So input rate vertex, perfect, and then we will have the stride, which will be 0 because we don't have anything like that, right? So no, fuck, stride. That would already have been gone wrong. Fuck, that is the size of our vertex struct, which is like per info, but what is? It's literally just a. Oh, it's this. So I could take 4 times that, or yeah, okay. I'm just gonna say C dot. Was it Vulkan? Or was it? That was XR. Damn. XR vector float 4. I think a float 3 would have been enough, but
Oh, Lucas, I'm into nuts.
no, don't do that.
I have access to all the nuts.
Okay.
There's a lot of yummy salty nuts in here.
I can't. And then now we had the input binding. So I'm gonna call it vertex, no, action input. Vertex input, or input vertex input. C VK vertex. Oh wow, it already gives me the input that like so is equal to, and then this, and we can do that. And we're not gonna have two of them because we don't have two. And this one is associated to the first. And then format. I don't actually remember. Let's take it a bit later. Location is 0, I think. Oh wait, we haven't even changed the shaders, but we will change it to take a in position, so this one will be gone. But 0 and offset, well, that will be the C, was it, I don't remember, is it just float? I don't remember what the type was. VK shader, let's see, where do we have this beautiful okay, wait, I know, if I type red 32, that's not red 32, here, VK format, that's what I'm searching for. VK underscore format, red 32, and then float. But I need actually the largest type. I need that with the Isn't there, is the largest actually just with 3? I need 4. Red, green, blue. Oh, I missed it. Boom. Like so, not that. And format. Oh yeah, this was C, VK, and then what the fuck? Something vertex, right? I don't remember that. Okay, I need a bit of cheating. Oh, I mixed the format. Damn it! I haven't watched your stream for a while. Did you achieve anything other than that triangle? Yeah, I got the spectator view up and running, so now you can see what I see on the screen at the same time. But more than that, no. Have not achieved more than that.
Well, I managed to get into these yummy nuts.
What the fuck?
You know, they are delightful. Yummy, yummy.
Yum. How do you do the offset thing if you use SIG? So what's your goal now? Now I'm gonna make the vertex buffer so we can get a plane, and then I'm gonna fix the interaction so I can move around a cube. After that I will clean up this whole code base so we can just call a function to load in models, and then we can actually start making the game. But for now, just trying to get the base thing that we can move stuff around, interact with stuff, and then I will clean the stuff. That's like kind of like the two major things. Get the base working and then clean it, and then we will continue with making the real game. But how do I do this offset thing in SIG?
Are you trying to get the offset for like a struct field or what?
Because it's like, so you're now setting up 3D world after VBO, basically.
Well, if the offset here, like, is that the stride?
This is the stride here for the binding, but this is then for the input, so I'm a bit...
Well, like if you want the offset for like the individual components or whatever, then you can make a struct called like vertex, and then inside of that you can put a field like
But
position
wait,
or something, and then
it's like here this thing. Formal parameter is implicitly defined byte size of attribute data, and the offset parameter specifies the number of bytes since the start of the per vertex data to read from. The binding is loaded on
I don't know,
vertex
man.
at the
I
same
think
time.
your stream is bugged.
My actual stream or my Discord stream?
Discord.
Ah, well then I can just restart that one. Let me just do that real quick.
And boom, your entire computer just crashed.
No, I'm using Hyperland now, so guess what? I can just re-plug in my VR headsets as I wish. And it doesn't bother anything.
Congrats.
I know. Parameter implicit defines a byte size. Offset parameter specifies the number of bytes since the start of the per vertex data to read from. The binding is loading one vertex at a time, and the position attribute pos is an offset of 0 bytes from the beginning of the struct. This automatically calculated using wait, that's just so where it starts off, right?
Well, that would be. This is well. You see, you don't actually want vertex input to be just one thing. You actually want it to be an array.
Uh-huh.
You get me?
No, I don't get you.
Okay, well, you see this VK vertex input attribute description. That's like for every single component.
But I just have a single struct, which is this thing. Oh.
Okay, you only want. Well, this is like for the position and color.
But
For the vertex.
This is no. This is a whole vertex.
I mean, it can be, I guess, but like, what are you doing?
This is just X, Y, Z, and then W for some funny reason that probably shouldn't be there.
Yeah, but isn't this what you're trying to send to the GPU to render?
Yeah, basically just the position for the vertex of the cuboid, like for each vertex.
Okay,
Position.
are you storing anything in that vertex? Like you're storing the position in a vec3, I would guess, but or
No,
color or something.
I have a vec3. That's all I have for this. Like I have this position.
Oh no! Why are you using vec4s? No, it's such a waste.
That's what they do in here. I'm just following along like a good boy.
Brother, this guy stinks.
And why do we put? Why? Oh wait, no. Okay.
Bro, this is what this. What? You know what? No, you know what? No. What are you doing?
Don't worry about it. It's gonna work. But I'm just thinking like, what do I put for this offset over here?
As well, the cube in the C is wrong. It's in the, not in the.
What?
Right?
Where do you read cube in the?
You know, like the cube in this is the array. Like, oh, no, why are you specifying the length? No, who let you? Who has been guarding you all this time? Oh no, what's going on here? Oh well, no.
I just
Go for a week.
I don't like to leave things into guesswork, you know. I like to write quite explicit what is happening.
No, that's not how we do it in Sig.
No, that's how you
Not
should do
when
it.
it's
You
array.
should be explicit. Don't be implicit.
Not arrays in Sig. We try to just use the underscore. Okay.
No, I don't like the underscore. No. The unders-
Yes,
the
you
under-
love the underscore. Yeah, that's
No.
right. That's right.
Only if I don't wanna
Yeah.
bother to figure out what I'm actually trying to do.
Bro, this code base because of your style is so trash. What it is.
My C-style is the best
Oh.
thing here, bro.
This project. Oh hell no, the engine code is gonna be such a mess.
Don't worry about it.
Oh no. I'm just thinking about how big of a mess this is.
Don't worry about it. I have it all under
Okay.
control.
You have nothing under control, bro.
I have a triangle that renders both to the headset and to a spectator view. I think I have it under control.
Hmm.
But not
Yeah,
not
it's
right
probably
now.
gonna get like. So what are these cube vertices? Do you know how a vertex works?
Cube vertex. Wait, what did you ask? This thing?
Do you know how do you know
Yeah,
how
yeah.
vertices work at all?
Yeah. These are just the positions for each vertex in the 3D space. I don't know what the fourth is for though. I don't know what the fourth one is for.
Oh no.
They are
Oh no,
positions.
this is so bad. This is so bad.
How would you do it?
Well, first of all, I would stop using the XR vector effort, like the thing there, and using like F32s instead.
But then you would
Right.
have to say array of array of array of array.
What? No, it's just an array.
Or you
Like
mean
also remove all the like curly braces, like just have numbers, you know.
you would
Yes, and then I would
No.
combine the normals into the cube vertices because that's how vertices work.
No, I mean yeah, you could. But we can do that later. Okay, this is just a test
Oh.
setup for me to see like how they do it in this thing. What?
What? No, bro. We're gonna rewrite it all, bro. This is just scraps.
Do you actually use normals? I never used normals.
I use normals a lot, bro. It's like the best way of doing shading without having to do anything complex.
No, I just did ambient occlusion. Yeah.
Yeah, but that was Minecraft. It's different. It's easier there.
Yeah. But this is still valid. Don't worry about it. This will also be actually deleted once we have it all set up. I'm just trying to figure out like how they do it in the tutorial OpenXR. So don't worry about it. Well, then we will have to rewrite the pipeline. But that's fine. I'm still curious to know, do they do anything with this? Because I'm like, why would you give a fourth parameter if you don't use it? But we'll see. But yeah, we haven't still gotten an answer to what the fuck I'm supposed to do with this offset. It's just supposed.
Well, you see, normally the vertex would have like a bunch of shit. It would just be like one array, and the offsets are used for separating the actual vertices so it knows which data is for what.
No, but, I mean, the stride is basically. Oh wait, the stride is the whole size of the thing, and then this thing is just the size of. But why do the calculation? Yeah, but why do the calculation? Couldn't they just have said size of pos and then size of color? Why do this whole thing over here? Oh, they
well,
can.
it's to do with Vulkan, I believe. It's like you have to get the ins like working so you can actually get the actual data inside of the shader. You have to like tell it what it is, because otherwise it just doesn't know.
And then it's probably just at size off for me, and then just the struct that I use. Like that. Oh god.
Wow, this is not gonna work at all. Damn.
You are too doubtful, my guy. Oh yeah, then I
Looking at this code, I don't know.
Ye-
I don't know.
ye-
It's such a mess. Also, it's like you're not sticking to a style either.
Oh yeah, because I'm I'm doing two kind of tutorials at once.
Yeah, I know, but also like the SIG style. Like sometimes you put the struct type after the colon, and in other places you don't use the colon and just let SIG infer it, which is how I do it in with structs.
No, yeah, I changed
I
it.
don't think
Like
there's a right or
I try
wrong.
to do it right now all the time because Cheesecake told me that, for example, I do it here in the not here but here. That if you say the type before, you can just do this init after, and then you SIG doesn't infer it. So you can just do this immediately like that. It's really nice.
Yeah, I know it is nice. Maybe maybe I am doing it wrong and should stop doing it that way. I mean, I just listen to what Cheesecake says, but the issue is that you're using both.
No, yeah, but it's kind of like I learned this like 5 days ago that you should do like this. So now I'm just trying to do it all the time. So I don't know where do I use the
Well,
other
I
way
learned
around.
that now, like everywhere.
Okay, I guess I use it here. But it's like
Yeah, but that's different. It's different. It's like a cint. You don't like for structs that you made or that are SIG style that actually have methods. You could absolutely do it that way, but yeah.
I don't know. But yeah, I still prefer using C libraries as C libraries rather than using wrappers.
I did the exact same for a long part of my SIG usage, and then I was like, I don't really like using cints everywhere, and I was like, I'll just use a wrapper. They're very nice, very nice.
But no, I don't know.
Bro, I had the exact same like train of thought, and I finished later.
That like the somebody wrote like the guy who writes the wrapper still has to translate it, like do a endpoint, so you just use the SIG endpoint. But I think it's the way it's done. I feel like it's like removing like it's a different way to initialize everything and set everything up. I don't like it. Bro, Vulkan and C++ drive me crazy. Nobody said I need ducking shader and CMake. It's kinda easy. What? Okay. I will just hope for that this is okay, you know?
Yeah, it's not. But the reason why you like the C
Yeah, it's
libraries more
not. What?
is because of you don't understand the SIG way. The SIG way is the best way.
But C we.
Bro, this is SIG. This ain't true.
But C is so nice.
No.
No. I'm trying to write in C++ first time with Gemini. Yeah, Gemini is fine. But sometimes it just spits bullshit at you, so be careful. Introduction. Let's see. Vertex buffer creation. But this one I already did. But let's see how they connect with this thing. Buffers in Vulkan are regions of memory used for storing arbitrary data that can be read by the graphics card. They can be used to store vertex data, which we will do in this chapter, but they can also be used for many other purposes that will be explored further chapters. Unlike the Vulkan object we've been doing so far, buffers do not automatically allocate memory for themselves. The work from the previous chapter has shown that Vulkan API puts the programmer in control of almost everything, and memory management is one of those things. I wonder though, like, if you allocate memory on the graphics card, right? And then you forget to free it. The operating system won't go in and free it for you, right? So if you leak, or like, can you leak memory on the graphics card? That's basically my question right now. Like, if you
Maybe, I don't know.
Because at least modern operating system right now, I'm not afraid of leaking stuff, because I'm like, once I close the application, the operating system will also know that it will go. Of course, I will not leak leaks, but I'm like, you know, it's not an issue because the operating system will still clean it up for me. So I can kind of like leave some leaks just there because, And also I got 64 gigs of RAM, so I think I'm good. But yeah, of course, once I'm done, I don't like to have leaks, but like I can do afford a little bit of leaks just to see that, try things out, and don't think about freeing stuff before I actually need to free it. Create new function. Gemini is so smart, but memes suck. Yes. Create new function. Create vertex buffer and call it from init Vulkan right before create command. Okay, but I'm not doing this. So now we can look into this thing, and that is what I just created here at the bottom. Boom. Buffer create info. So we have here, and then buffer size is size of multiplied by this. Oh shoot, yeah, I need to say, because size alone won't be enough here. Okay, I will maybe change this to len, and then I will tell it to be another, which will be type size 32. So then that will just be like, hey, you have to pass both of these, and then you can just say len multiplied by type size. And the main will probably have to change a little bit, so it takes in, goes here, and then we'll have to pass in type size, so we'll be at size of CVK. What was the thing? I forgot. Oh, it's XR. Vector F4, that. And then I will just yank this, paste it in here and here, like so. And this one also needs to take the address actually. Boom. Alright. So now we will have that. First field of the struct is size, which specifies the size of the buffer in types, in bytes. Wait, what? The first struct is size. Size of buffers in bytes. Calculating the the type size of the vertex is straight with size of. Buffer usage. Second is uses, which indicates for which purpose the data in the buffer is going to be used. It's possible to specify multiple purposes using bitwise, or our use case will be a vertex buffer. We'll look at other types usage in further chapters. I think might have to do something more here. Because doesn't that one also has to be checked here? I will actually change this to just be usage, so you will pass it in as a parameter. So I will just add it to all of these because, yeah. All right. Sharing mode exclusive. Yes. Just like the image in swap chain, buffer can also be owned by a specific queue family or shared between multiple at the same time. The buffer will only be used from graphics queue, so we can stick to exclusive access. This is, because I think I could use this crate buffer also for the swap chain. So I might have to change this to a parameter. But we'll see. The flex parameter is used to configure space, buffer memory. It's not relevant right now. We'll leave it as default 0. Sparse, wait, space. Did I say space and with sparse? Brah. We can now create the buffer with VK create buffer, define class member to hold buffer handle, call vertex wait handle and call it vertex buffer. So sharing mode and then create buffer. Well, yeah. Just gonna do this because it's easier to read. The buffer should be available for use in rendering commands until the end of the program. It does not depend on the swap chain, so we can clean it up in an original cleanup function. Memory requirements. The buffer has been created, but it doesn't actually have any memory assigned to it yet. The first step of allocating memory for the buffer is to query its memory requirements using the aptly named vk get buffer memory requirements function. It has 3 fields: size, the size of the required amount of memory, required amount of memory in bytes may differ from buffer info size. Alignment the offset in bytes where the buffer begins in the allocation region of memory, dependent on buffer info usage and buffer info flags. Okay. Memory type bits, bit field of memory types that are suitable for the buffer. Graphics card can offer different types of memory to allocate from. Each type of memory varies in terms of allowed operation and performance characteristics. We need to combine the requirements of the buffer and our application requirements to find the right type of memory use. Let's create a new function, find memory type, for this purpose. Yeah, okay, so they also did it here. First we need to query about, graphics card cannot type of memory to allocate it from. Each type of memory varies in terms of allowed operation and performance, but why would you still do a different type? That I don't know. First we need to query about info about available types of memory using. So here, and then you do that. So now I can get a little bit confident with this thing. Okay, let's go. Physical memory properties. Structure has 2 arrays. Memory types. Wait, what? It has structure has 2 arrays. Memory types and memory heaps. Memory heaps are distinct memory resources like the dedicated VRAM. I think I did it. Oh my god, nice. What did you do? Dedicate VRAM and swap some space in RAM for when VRAM runs out. Different types of memory exist within these heaps. Right now we only concern ourselves with the type of memory and not heap it comes from. But you can imagine that this affects performance. Let's first find a memory type that's suitable for the buffer itself. Yeah, that's this one I like more than count type filter. Oh yeah, I have a triangle in C++ Vulkan, my first. Amazing! You need to post that on the Vulkan subreddit, you know? Everybody likes when a person gets their first triangle up and running in Vulkan. It's a big deal, so... And also do it on the Discord server, because it's a big deal for me. So, do it. Oh no, I pressed the space button, no. Okay, the type filter parameters will be used to specify the bit field of memory types that are suitable. That means that we can find the index of suitable memory type by simply iterating over them and checking if the corresponding bit is set to 0. We will be used to set the bit field of memory types that are suitable. That means that the can find the index of suitable memory type by simply iterating over them and checking if the corresponding bit is set to 0. However, we're not just index Vulkan or DirectX, or does it not really matter in your opinion? I have just done stuff in Vulkan, so I don't really have a fair say in any of the other graphics APIs. What?
Just say Vulkan.
The only reason I wouldn't use DirectX is because Windows. But yeah. When you fix it, you post it. Alright, good luck. I'm going to sleep. Tomorrow I'll fix the triangle. Alright. Well, good luck. And I'm expecting a box. I'm expecting a cube also tomorrow. Alright, do you understand me? There better be a cube as well. Nah, a quad is good enough. You can do a quad. Mm. Yeah, but also, Clint M, Vulkan or direct, or does it really matter in your opinion? Like, what do you mean also by that question? I just don't know because I have only used Vulkan, so I don't think I have a fair say in any other of the
Yeah, you
APIs.
you submit it DirectX. It's the DirectX of the graphics libraries, so just use Vulkan.
Can be rect, it's the same. Yeah, rectangle is the same. Well, quad is a rectangle. A quad is basically when you have two triangles to make some form of square, rectangle, whatever. See, I'm going to sleep. All right, good night.
Or a plane, but a plane is a quad that is laying down, but still.
Well, quad. Quad. However, we're not just interesting. Well, yeah, no, that's quite. Yeah. Just interested in memory type that is suitable for the vertex buffer. We also need to be able to write our vertex data to the memory. For the memory types array consists of VK memory struct that specifies the heap and properties of each type of memory. The properties define special features of the memory, like being able to map it so we can write to it from the CPU. This property is indicated with the VK memory prop host visible bit. The property memory, like being able to map it from, we can write it from the CPU. So VK host visible bit. So host is CPU, but we also need to also use the promote host coherent bit. Probably we'll see why when we map the memory. We can now modify the loop, so also check for the support of this property. So type filter and mem property mem types I property flags properties return I. Yeah, I should not probably return it through. Oh shit. But I need to do one thing. I'm gonna take this and I'm gonna go to here. This is how I'm supposed to do it. You can do this. That's also what they do here. I don't know why they did it differently in the OpenXR tutorial. But it's basically this one that I also need. Yeah. So then we can go into here. And I will basically replace this loop with that. So we'll have Shift E, and then this properties, which is physical device. I think I will just call it properties. Properties. We'll go through, and then requirements. So then we take the next one, and then we check this, that this flag. If it's not, then we do that. Else we just have memory index being that. And then we don't need this.
Lucas.
Hmm?
Look up. It says gullible.
Gullible? Where?
Yeah, on the roof. Look up.
Just no, it doesn't.
Did you check?
No. Yes, I did.
Check again.
Wait. There's people in the chat. DirectX works only on Microsoft system. Yeah. Alright, makes sense. Just feel like doing a low-level graphics API would require a lot of prerequisites. A lower level lang like C or SIG and advanced math topics.
Nah, don't use Vulkan. Use OpenGL.
I don't know. Like I when I started with Vulkan, I didn't know anything about graphics programming. I did know low-level programming as C, and Math I knew about. I I I I knew a little bit about vectors because I have done a little bit of game programming, but that was about it. And well, I think if you can program like low level, well, you can learn also programming while doing it. And I think if you can understand that, then you can learn like the other things are kind of like, because you can just analyze and see what the data actually means and represents, and then you can debug it quite easily. Yeah, and what Dogoman said exactly. Hear me out. Fuck around and find out. That's literally like that's my go-to. That's like
no.
It's so fucking good. Like just mess around. You don't have to be perfect. You have to do shit.
No, you have to.
Perfection
No, you have to
is
be
the enemy of what is it? Progression.
Lucas.
What? Vulcan?
No, it's enemy of Lucas.
The enemy of Lucas. Yes.
Yeah, of course.
Yeah. Okay, wait. What are these flags? Are they a parameter I should be passing in, or? I think they might be. Let's see. We'll go a little bit down. Because these are the flags that I'm supposed to be checking: property visible and host coherent. I'm not passing that information in at any point. And I'm thinking maybe I should...
There are no red flags.
What? I'm learning SDL3 and C++, and I'm kinda know what I'm doing now. Hell yeah, see? Dogoman is fucking around and finding out.
Yeah, like SDL3 is like that's Vulkan if you don't want to spend a year on the, like, I don't know, finding the right GPU.
I guess, but it's still fun to try to connect all of these things and understanding how the thing works.
No.
And it's also fun to I also like debugging Vulkan. I don't know.
What?
I just wish I could get my validation layers to look a little bit better, because they look horrifying, but they're fun to read.
You know, I thought you were gonna say something about not debug, more like, yeah.
Let's see. I made a really basic game using Java graphics 2D, and I can't even get a basic AABE collision resolution working. Never mind using a low-level language plus a graphics API. You guys are gods. Ah!
No.
I'm just a dumbass doing shit I probably shouldn't be doing.
Yeah, Lucas has no idea how to use SIG, by the way.
That's true. Harold is having a heart attack every day he comes online and sees me write something in SIG.
Yes, it's so bad. It's trash. I get my body starts to hurt.
But that's because it's you have to see. I'm a C addict.
I have to see. No.
Yeah, you have to see I'm a C addict. You know, I love C.
Yeah, I realized.
C is right here for me. It's right in the heart, in the soul, in the body of my whole existence. I wouldn't exist if it wasn't for Z. You know.
Well, in that case, you should probably just unalive yourself.
Oh wow, that's so kind of you to say.
Yeah, I know. You can thank me.
I got your back, bro.
Yeah, I always got your back. Always got your back. If you know what I mean.
Oh yeah, but these are the other bits. I'm just gonna change them to be... This is not used anymore. Type bits can be... Yeah, but I don't do that. And then I replace this with that, which is the same flags. Host coherent and
yes,
host visible.
That. Yes.
Yes, they are the same. Just better variable name. You can let AI help you make code, but don't let it write all of it and learn from it. Yeah, that's it. That's what I've been doing, and it works for me. Yeah, I agree. Like, AI can help you a lot, but you have to understand what it gives you as an answer. But also like
No. You have to just be a better prompt engineer.
prompt
You guys are understanding it wrong. You have to say it's Linus Torvalds that is writing it. It's 2005, and it is very important because if he doesn't complete the code, then your grandmother will die. And you have to say please 10 times in the sentence, and then if it doesn't do it, then you have to just do a bunch of swear words and hope it gets it.
I don't know, man. Like, I tried today. I broke my. I set up an AWS server for the Discord bot, and I got problems with my. What was it? It was something with my Docker file, and I explained a thing for it once, and then it was like okay, and then it responded, and then something else was wrong. I was like, no, you got it wrong. This thing has to be like this, and I was like, okay, I got it. So now that you got the second thing wrong, but the first thing was incorrect. Now I was like, oh my god, please. So then I explained the both of them again, and then it still answered incorrectly. I was like, you know what? I'm just gonna Google at this point. This AI is so dumb. It's like I don't know, man. It's sometimes it's good, but sometimes not. I just let it.
It like worked once when I asked it to just write code because I was lazy, and it just did it, and I was like, what? It works?
But yeah, I'm getting like I don't know. Either AI is getting worse or I'm getting better. I think it's the first one because I feel like I'm more and more trying to correct the AI before it even has answered completely. I already see the first 3 lines. So like this is completely a bullshit answer.
Because I think the AI is getting worse and you are getting worse. Everyone is getting worse.
Exactly. But yeah, I think the question is not like if it's easier or like what you should do, if you should do it because if it's hard or easy, you should just look at the thing.
No,
and
the real question, Lucas, is it hard?
Yeah, exactly. Yeah, it is. But you should just look at it and be like, if you really want to do it, it shouldn't matter if it's hard or easy. You will do it either way. And I think, especially when it's more difficult, you have just a higher potential to learn from it. That's one of the reasons why I also chose Vulkan rather than going OpenGL first, because I just saw it like people just said it's gonna be a lot harder to learn. It will be a lot harder, a lot more to learn. I was like, well, that's exactly what I want, so I'm gonna go for it. And yeah, I like it. I actually find it fun to trying to connect all of these pieces together and like slowly and surely learn more about how Vulkan work and like how these pieces connect and work. And even like I can have like the most stupid problems in Vulkan, and then just like trying to figure out like either have like reading the validation layers or then going into an actual debugger trying to figure out what the fuck is happening. And like eventually like if you just tweak values, you will like that you have to make some assumption, like heuristical assumption of what could be wrong, and eventually you will just start to see patterns. Like this is usually the case of that when something like this breaks over here or there, and that you can always transfer that knowledge over to another project. And especially when it's the lower level you go, it's like you start to kind of think, even when you go to a high level language, you already can see like what's actually happening under the hood. You can kind of like see that what's going on over there, and then you can already start making an assumption of why the abstract high level language breaks.
TypeScript. I have no idea what's going on under the hood.
Well, that was just awful. But that was too high of a step, you know. It was too high up. It was too much.
Not even programming.
Not even programming. I think we should have done it with cursor. You know what I'm saying? Nah, but the AI bot was fine. I think we would write it completely differently if we did it again. Probably not in TypeScript. We would do it in C. Am I right? Or Sig? You didn't just learn Sig, you absorbed Sig. Model Vulkan to your will. Exactly. No, Vulcan is molding me to its will.
Yeah, that's what I thought.
And then I'm molding Sig to C.
Yeah, and I hate it. Every single second of it.
I'm like, we should take one of those memes where they say like the phrases incorrectly. You know, the phrase meme. Let's see if I can find it on like just by doing this. That's not how you spell phrase. How do you spell phrase? I'm having problems, guys. No. What is the meme where phrase spell sentence meme? Come on. This is how I'll find it. Oh, I can't find it. I thought that would nail finding the meme. But you know where they say I think it's from Friends. This is such a side track.
What
Here!
friends? I don't
Here,
know.
this
I
meme.
don't have any.
You know this one, right?
Yes.
So, well, you try to teach me, you know, SIG, and then at the end, like, you say the whole SIG concept is, so C, basically!
Yeah. But you know, when you're molding Stig to C, you know, I got a funny idea. What if you made a video where you try to misuse a language as much as possible? Like, instead of using the standard library or doing anything like a normal person or following guide, like how you should write it, you just write your own shit and just you follow your own shitty style and reinvent the wheel every time you can.
Well, that's just C. Who uses the C standard library? Who uses C external libraries? You write everything from scratch every time.
Okay, well, you know, in a normal function, well, no, bro, they really took that functional. No, I don't mean like Haskell. I mean that it's working. This is so bad. Why did they take the name?
Would you rather learn SIG or be happy? I would rather learn SIG.
Learn Sig.
Happiness is
Yes.
overrated.
True.
True.
We even need that.
Who needs
What is
happiness?
that even?
Yeah. When you got SIG, why would you need happiness? No, but life is a lot easier when you don't need to be happy, you know. What was I supposed to? We have now. I need to get some memory allocations going here. We may have more than one.
Not you with allocator.
Yeah, one desirable property. So we would check if the result of the bit was and not just non-zero, but equal to the desired property bit field. If there is a memory that type suitable for the buffer that also has all of the properties we need, then we return its index. Otherwise, we throw an exception. Yeah, I should probably do that. Don't I do it in this one? I don't do it here. I should probably, if I ever reach that, I should probably. Is it panic, or what is it to throw an exception, or the equivalent?
Well.
Is it panic?
Oh no! This goes so bad.
I don't know how to do
No,
this in
no,
a sick kind of way, so I'm doing it like this, okay?
It's so bad.
It works!
so bad.
It works!
It's so bad. It's so bad. Ugh, what am I looking at?
How would you write this in SIG then? I don't think you can get it more compact in SIG. I think C is the way to get it actually this compact.
No. It's called an OR.
You got an OR?
Or, you know, like pipe.
Oh, you mean instead of doing 2 if separate conditions?
Yes.
Well, I guess you could do that, but
Yes.
oh, no, you mean or?
Yeah, and also it's or. Yeah, I know, but I know it was just because I know that you are a C-brainer. So I was like, how do I explain this to this noob? Anyways, I would also remove the curly braces for the if statement there and just let the continue be there.
I would almost like to have a separate line like this for it.
Yeah, that's fine. That's fine. But remove the curly braces.
But how do I keep it like that?
You don't.
No, fantastic. What if I had more curly
Yeah.
braces? Could it then work?
No.
It didn't.
Yes. Mm-hmm.
Wait,
And also in the else there, I would not do the curly braces. I would just do panic,
panic
because we
mode.
don't do anything else.
Do I just say?
Yes, but I mean, I would probably throw an error, to be honest.
Do you mean return error?
Yes.
Return error. Did not find. What did we not
You
find?
could not try to panic because it's all just fucked.
I don't know. Panic is nice for me. I don't know what you're talking about. Error is unclear.
No, we do error. We do
Error.
error.
What should I
I
say?
don't know,
Because
just right.
it did not find memory requirements. Can I just say memory requirements?
Yeah. Mempory. Yes.
Shut up.
This is the pornitor over again. Do you guys know about the pornitor? The portable monitor. Yeah, exactly. I mean, what were you getting at?
Oh no.
Search for pornitor.
Oh no, I'm
Trust
not.
me.
No, I'm good. I'm just gonna fix this one also too.
It's not like my company when they try to do advertisement for their new monitor, but it was also portable, so they combined the two words portable and monitor and it became pornitor.
Oh yeah. I've heard of it.
Yeah, I
actually.
only use monitors.
Wait, is this correct now? So it goes through here and then it checks.
Yes.
This is incorrect.
Yes, because you have not removed this curly brace.
No, I have. Do you not like object-oriented programming? Yeah, I don't like object-oriented programming.
We don't like it.
Yeah.
We don't like it.
It's like it started off kind of nice, but then it was like the more I read on it, the more I was like ugh. And yeah, now I don't like it that much. I thought it was super cool when I started doing or got introduced to object-oriented programs. Like, wow, we can do this and you can do that. Now I'm more like, yeah, no.
OOP is kind of like that old dude who sits out the side of the supermarket every day.
Sure.
Yeah, there's nothing more to the story.
I'm beginning to hate it now.
Anyway.
Yeah. You should wait. Oh fuck! It's not here. It's here. Bruh. I have a great channel for you. You might know this guy. Oh, they have released a new video. Woo! This is really good. They talk about low-level programming and especially this one. This is really good. And then there's also well, there's other good videos, but I think like this channel is just awesome. It's really nice. deep learning and computer vision for game developers. Yeah, so I think I will watch this soon, but I'm not gonna watch it during stream. I usually try to watch it after I get home from reading, and then after I watch that, I go live. They upload like daily, so it's really nice. And really good content. Really good, really good. Now let's see with this if condition. I need to keep this. They would probably not like the way I write code. Probably not.
No one likes how you write the code.
I like how
The code is so bad.
I like how I write my code. It works.
No,
The main
it's
thing.
not unacceptable.
The main thing is how if it works
After
or
the
not.
or.
What?
The problem is after the or. You are keeping a parenthesis after the or, and it is bad. After, remove one of those. Yes. Yes.
Yes.
Yes.
Sweet, thanks. I'll look at that now. Yeah. No worries. Enjoy. And welcome to low-level programming or data-oriented. But yeah.
The YouTuber low-level programming. Okay.
Yeah. Well, I guess that too. He's good too.
But Lucas, everyone knows that the best one is you.
Oh, thanks, man. I know you don't mean it,
No,
but thanks.
yeah, that's and not again. So it's like reversed, you know.
It's a not. It's a not gate, which becomes a true.
Yeah.
You know, that's how I
Not
I
anything.
also do my if conditions like this. You know, if not true. You know, and then I do the thing.
Mm. Yeah,
Because then
that's
it's-
the best syntax.
Then it's true. Oh, Christoph! It
Yeah.
joins with 54. Damn, that's now it's high pressure. There's a lot of viewers, and they are expecting to see something, and I'm like, I don't. It's
Yeah, we don't
broken. I hope at least the stream quality is up to speed. That you see that.
Also, bye.
Alright, see, you're leaving now when everybody's joining. SMH, bro. How could you?
Bye.
Alright, bye.
See ya.
See ya. You now have a way to determine the right memory type, so we can actually allocate the memory by filling the VK allocate infrastruct. Yay! So this thing. Should probably take it down, not do it up here because it's not relevant yet. Yeah, it's here, it becomes relevant. Boom. So. And then this one is also more relevant this way. Ooh. Okay. So then we fill in the information with memory requirement size, and then this thing find, yeah, we oh, so they pass it like this, then you could make a parameter, and that's why it would make sense to have this as a function rather than but I don't like creating a function for that. If I were to use it in multiple places. Besides that, I think this is just horrible to make a separate function for that purpose. So I'm not gonna do it, in other words. Okay. So then we just take the dot memory type index, and that we got from here. So memory type index, boom, done, easy. Then memory allocation is now simple as specifying the size and type, both of which are derived from the memory requirements of the vertex buffer and the desired property. Create class member to store the handle to the memory and allocate it with vk allocate memory. Boom. Yes. And then let's see. Yeah, but I do a try, so I will. Yeah. If memory allocate was successful, we can now associate this memory with the buffer using. Okay, so then you do the binding, and then that's that, and then yeah, I will actually take. No, yeah. So you pass in the buffer, the memory, and you don't need to use that. The first three parameters are self-explanatory, and the fourth parameter is the offset within the region of memory. Since this memory is allocated specifically for this vertex buffer, the offset is simply 0. If the offset is non-zero, then it's required to be divisible by... Okay. Of course, just like dynamic memory allocations in C++, the memory should be freed at some point. Memory that is bound to buffer object may be freed once the buffer is no longer used. So let's free it after the buffer has been destroyed. Yeah. I don't... Where do I call these ones in the beginning so I could do a... in the D init here. Why? Yeah. Destroy session, destroy instance, and then device. So before it has to be destroyed before destroying the device. C ek destroy. Ah, they put a comma. I was like, that should be it. Ek destroy. So whatever, buffer.
Yo, I'm back.
Yo, welcome back. You just missed Harold. He was here.
Oh, hell no.
Hell nah. And he just
Whoa.
left like literally 5 minutes ago. By the way, we also got Christoph underscore T IT, bruh. He raided me on Twitch with 54 motherfucking viewers. Crazy. I don't know where he gets these viewers from. It's many.
Crazy.
Yeah, so the vertices buffer and null pointer, and then
And how's the project going?
it's going all right. I'm actually rereading the Vulkan tutorial to get a bit of refresher of how these buffers works, because I am lost indices, cube indices, and then we will have to free the normals as well, like so. Now the issue is that I only return the buffer, but I don't return the memory. Shit. Maybe I should do that. Maybe. Is there a... There is probably a... Should I just return the... I will just return a struct of it. Or should I return... I will not. I will return the same way that we do with the is the create pipeline here, because it returns the pipeline and then the layout. So is it a
Or does it return like?
Yeah,
I think it's.
Yeah. I didn't think you could break it though. That's why I'm confused. But you can break it, huh? Okay.
What do you mean with break it?
I will show you. So we will do this, and was it struct, and then you just say here, well, it will be, yeah, this will be a CVK buffer, and then we'll return also the CVK memory.
Yeah.
Is it just memory? What is it actually called?
I think it's device memory.
Device memory, yeah, that's VK device memory. Device memory, like so. So we'll return that. And not that. Okay. So then if you go back to main, we create, we init, and in the init here, yeah, I moved it like this. Well, I guess I could change this actually to be a struct. That would be maybe a lot cleaner anyways, because they will always be connected. That I will never use like one without the other.
I still think I have it.
Yeah, you showed me. And also just having those void pointers at the moment, so I probably it's a bad idea anyways the way I'm doing it. I will literally just create a struct here. I will move it out from here later on. How did you do it? It was pub. Oh wait, there is pub const. And what did you call it?
Struct now?
Yeah, I'm changing.
Or what do you want to do?
I'm gonna change it to be a struct.
But
how did you do? What name did you give it? Just Vulkan buff?
just Vulkan, yeah, Vulkan buffer. But Vulkan like typed out, written out, yeah.
Yeah. And then equals struct. I'm thinking. What am I? I'm not thinking. That's the issue. And then here we'll put the. I would say just buffer. CVK buffer. I might put this actually inside of the Vulkan.
But you're doing actually even more than I'm doing. Like I only did the VK buffer, like the Vulkan buffer with a VK buffer and the device memory, you know. You're now also putting in the data, which isn't that bad actually.
Yeah, no,
makes sense to put it.
Yeah, right now at least it's not that bad. Vectors are not allowed to be between yeah, that's don't worry about it. I will put this inside of the Vulkan file itself. Or should I say? Yeah, I will put it here. So then we will return a Vulkan buffer. Okay, this is starting to piss me off now quite good. I'm just gonna do this like so. And then we will just return a Vulkan buffer. Vulkan buffer memory. I will call it Vulkan buffer. And then in here we just change this to be VK Vulkan buffer, and I could do this a bit smarter. Bruh, how did that happen? So like so, and then in so here this thing should be fine. We just assign them then here, and then in the dinit we just call self. Yeah, I don't know what I was thinking here, because this is now oh, it has to be self. I was like, where is it? Vertex buffer dot buffer. Oh my god. And then this one would be index buffer, and then this will be normal buffer. Like so. Actually, they could be in the same buffer, the normals and the vertices. But they're in the separate now. It's fine. It's still just seeing how a bit of refreshments, you know. And then VK free memory. And I'm gonna go. For fuck's sake. Actually, this is better. Like so. Okay. Okay, it didn't get me all the way down there. Oh no, I got it. So do that, and let's see. It's the device, the memory, and then null. What did I remove? Yeah. Yeah, okay. Self.logical device, and then vertex buffer.memory, and then null, like so. And then we'll yank that, and then we paste it 3 times, then we'll go to the and then we'll type the index buffer and then the normal buffer, like so. For now, I think that will be fine. We will, of course, completely rewrite how that will work, but that will just see that we can get something basic up and
Because I
running.
think Harold's loader, I'm not sure if it uses, I think it uses only one array for like normals and stuff.
Yeah, like right now I just have, if you look inside here, I have a separate normals vector, but this could literally be inside of a struct, like
Yeah,
instead of
merge
having
into
this.
one.
And then you would just say, we don't even need this is such a waste of memory. It's like 25% larger now, the whole structure, because of this. But this could also be put inside of here, and I think that would also just need like 3, so you would only need 6, right? 6 32Fs, right? So 3 for the position and then 3 for the normal. And then we could get rid of these for both of them. But the XR tutorial shows using it like this, so I'm curious to find out why, kind of. So that's why I'm gonna do it as well like this for now. So yeah, let's go like that. Okay, filling the vertex buffer. It is now time to copy the vertex data to the buffer. This is done by mapping the buffer memory into the GPU accessible memory with the VK map memory. And yeah, that's also what I do right here at the bottom. Boom. Except that I do it incorrectly. What is the size anyways? It's buffer info size. Okay, yeah, so I don't have to do the recalculation. Buffer, for fuck's sake, I know it's here. It's called buffer create info. I should have access to it within this scope still. Buffer create, I don't know why, whatever. Size, like so. And then, yeah, this one just takes this function allows us to access a region of the specified memory resource defined by an offset and size. The offset and size here are 0 and buffer info size, okay, respectively. It is also possible to specify the special value VK whole size. That's what the other tutorial that I followed, I was like so confused. To map all of the memory. The second to last parameter can be used to specify flags, but there aren't any available yet. In the current API, it must be set to value 0. The last parameter specified the output for the pointer to the mapped memory. Yeah, so we will now get this one to the mapped memory. It's any opaque, but I think this was fine to do. We'll see. And then bada bing, bada boom, bada bam, bam, bam. And then unmap. Yeah, so then you do mem copy. But we have a little bit of a special case for our beautiful SIG. I don't know if this is the right way to do it, but it's the way I'll do it. Boom. We'll take from 0 to the size and the source.
The first time I saw like that you actually need to mem copy in Vulkan, like for real the data just in the buffer, I was so surprised.
Yeah, but it's because this is like to the GPU, so you get like a point. I don't think you get a pointer directly to the GPU.
Yeah, it's basically like malloc.
Yeah.
It's basically like malloc.
Yeah. But I wonder, is it like actual is that I think that pointer is still a pointer to a memory address on for the your actual RAM, right? It's not a pointer for the GPU, or is it a pointer to the actual GPU? I think Vulkan then like
So, no, I'm not sure. Also, like, really not sure. But how I think it is, you know, the thing with the host visible bit and stuff.
yeah.
They're like, and how I told you before, that's like that there's memory that's like, you know, the memory types. You probably have functions like to like get them, but basically, I think there's a part of GPU memory that like the CPU can access, and there's a part like that's like just device local, and it's different for every GPU.
Mm.
And I think how you're doing it right now, it's actually the pointer that's on the GPU, but it's like shared. You know, the memory is like shared between both. Like it's the GPU memory, but the host can see it.
Oh, so it's
But
it is like hardware position for these memories on the actual GPU still. That's what I'm wondering. Like, is
I
the
think,
because I was
yeah.
thinking like, is it still like in a kind of middleman state where it's like it's still like on the RAM on the computer, and then this when you start doing the when it executes the commands, it takes from the RAM over to the like you get a position in the RAM where the it's like kind of secured for the GPU to use, but I'm not sure
Mm,
like.
Yeah, I'm also not sure if I like told complete junk, but
Mm.
I think it is because you know the like videos from the German guy, he explained it like that some GPUs have like not much, like most of them is like things for device local, so that the CPU can't see most of the memory.
Yeah.
So if you have an older GPU that's like doesn't have much memory, there's also like a new feature for GPUs. I don't know what it's called, but
Hmm.
yeah, if you have an older GPU, what you can do is like make another Vulkan buffer, move the data to there, and then there's like a CMD function that you can call to move that data to the GPU memory. If you want, I can share you the code to it from
Yeah.
my
Be
piece,
nice.
I think. But yeah, I think that's like, but I'm really not sure if it's like, you know, if it's true if the pointer to the like that's shared. You can maybe ask AI about it.
Probably could. I think they maybe even mention it here. I will read it quickly here. You can now simply memcopy the vertex data to the mapped memory and unmap it again using unmap there. Check. Unfortunately, the driver may not immediately copy the data into the buffer memory, for example, because of caching. It is also possible that writes to the buffer are not visible in the mapped memory yet. There are two ways to deal with that problem. Use memory heap that is host coherent indicated with, yeah, we did that. Call, yeah, okay, after writing to the mapped memory and call before reading from the mapped memory. So call flush map memory range after to the after reading from the map memory. Damn. Okay, so that's why we just interesting. Like I can't even like Jesus, like calling the other things like it's so painful to manage like all of the coherency in Vulkan. And imagine having to do this as well. Jesus Christ, no.
But if you like think about it, that's like also one of the good parts about Vulkan because that makes you like able to optimize like really hard from the synchronization.
Yeah, I guess. True.
For example, in the German tutorial, they made it so that um, the GPU is so synced that the CPU can actually record the next comment buffer
Hmm?
while the GPU is still like rendering the image before that, because that's like the work that can be done without like needing to wait for the GPU, you know?
Yeah. Alright. I will continue reading. I think I'm getting this now. we went for the first approach, which ensures that the mapped memory always matches the oh yeah, also to show you maybe, I'm starting to get this now with the, here. So we create the pipeline, right?
Yeah.
Or the graphics pipeline. And here we need just to say that also, I'm gonna, that's why I'm reading these parts, because I think this, I need to understand like how these connect up to the layout. But here we have the descriptors, and you can see here I say binding 0 for both of these descriptors, but this is like, it's the vertex input binding and vertex input attribute. So this binding here is literally just like this thing. It says that, okay, we're gonna be like the first binding, like if you have multiple descriptors, if you have multiple like vertex buffers or different kind of shaders, yeah, then you need multiple of these ones. But if you just have this, then it's like the first one, and then you say like how big is one of these, the vertex information that you will pass into the vertex shader, so this thing over here. So you're basically the same. Well, we have one larger than this, but it's okay.
Wait, but the attribute thing is that actually makes when the binding 0, right?
Wait. Wait, vertex input trait. Yeah. So this is just basically telling that how we're gonna bind the shaders to the graphics pipeline, right? And then you have this one, and this describes the input. So how are we gonna understand the input like that we give to the shaders? So here you can see location 0. This is basically gonna be, you see I don't have an in, but I'm gonna write like a layout, and then it's gonna be location equals, no, fuck. Location equals 0 in, and then I'm gonna have a vec4 for pos. That's basically what that's gonna mean. Like, I'm gonna say that on location 0 we're gonna do this, and here you can see the format. It's 4 floats. So then the shader will understand, okay, it's expecting that something like this should be there. I'm still wondering, there should be a point where we say like the main function is called main, if I remember correctly. But yeah, and then
That is
here
the point, the pipeline thing, right?
this is create the graphics pipeline, yeah. And then here,
Yeah,
so
and yeah, that's the point in line 314 with the main function.
oh yeah, look at that. I was like, it should be somewhere here. But yeah, then here, yeah. Shader stage, and then you just say you pass the vertex shader, and then here it comes in, and then it understands from here that it's expecting to be like each vertex buffer that gets in, so it knows the size per like the segment for each vertex, and also expects that it should have a in location 0. So you have to do this. Wait, where did I already remove it? This. And then if you want more of these, you have to specify, like, for example, if you wanted to do another, like I wanted another input here from the vertex buffer, or well, it wouldn't be, well, yeah, then I would have to do, whoops, now I did something crazy. Oh no, I did something too crazy now. Oh shit. I'm messing up my shit. Okay, I hope nothing broke. Yank that. No, not this. I have to take this thing. Bruh. Visual mode. Okay, yank that. And then I can put it here. So then you would create another one of this input. But you can still use the same, you know, input binding, but you have to create another vertex input attribute. And then you just put this one to, remember, it has to also be binding 0, because it's still associated with, unless if you had them in different, which wouldn't make much sense, because I don't, well, maybe you could do it.
Yeah, it's binding 0, but location 1.
Yeah. And then you could have, if you, well, we could have normals actually here, so I could have done like here, I could have, well, the same one, you know, and just, then I would just change this to be well, they had to be in the same struct, you know. But then I could pass them in the same buffer and then use just different inputs for them, and then we could use them here
But
directly.
if you want to have a new shader, then you just do like a new vertex input binding, and can basically then you have a new shader with the new binding and can associate vertex attributes with it, right?
Yeah.
Yeah, okay.
This is the tricky part for me right now. It's kind of like, because what I did in the Minecraft Vulkan thing was that I created a new graphics pipeline for the skybox, the world generation, and then also for the UI. I don't know if you're supposed to do that, but I created like completely separate function calls. I think I could just have switched this out or something like that. I don't know. That's what I'm trying to like. For this one, I would like to make it. You wouldn't have to do that. You could just have it more dynamic, you know. So yeah, it's I'm trying to read and understand that now. Just gonna return also here. I don't know why it's not complaining that this doesn't return.
Even C does complain with a warning.
Yeah. I think my intelligence is broken. How does your NeoVim, does it complain if you would leave this? I don't know.
I'm not sure.
It's buffer and then VK memory. But yeah, we went for the first approach, which ensures that this map memory always matches the contents of the allocated memory. Do keep in mind that this may lead to slightly worse performance than explicit flushing, but we will see why that doesn't matter in the next chapter. Huh. Flushing memory ranges are using a coherent memory heap means that the driver will be aware of our writes to the buffer, but it doesn't mean that they are actually visible on the GPU yet. The transfer of data to the GPU is an operation that happens in the background. Okay, and the specification simply tells us that this is guaranteed to be complete as of the next call to VK submit. Okay, so yeah, just when you do this, it's not guaranteed yet to be on the GPU. So yeah, you I don't think you get a pointer to the GPU. You get a pointer to somewhere else in your memory, but which is kind of like more ready and secure maybe for transport to the GPU. Because why else wouldn't it be visible on the GPU yet? Or yeah.
Yeah, I'm really not sure, but I would find it pretty interesting how it's, because you know, if you like, it would be faster if you would get a pointer to the GPU. Maybe, I don't know.
Yeah. Let's actually just.
But what you can actually do, if you go to, I think, Vulkan GPU info, there's a site like that. There's like some site where you can see like okay, now wait, I think it's none of these.
Have you been
Wait,
to
let me. Nah, but the guy in the tutorial have been to it several times. It's been like, or maybe it's the first one, Vulkan Hardware Database. That can be.
No. This one you just see, or is it specific for each graphics card?
Yeah, but if you go to your graphics card and then, yeah, there you see the test. But if you go to it, maybe then go under memory on top. There, can you just go under memory there? Oh yeah, it is that. So there you can see the heaps and like the types, you know, and you see that for the most part it has like the most memories like has specific things, you know. Yeah, I don't know, but there's like memory heap 2 is like very small.
Yeah.
Yeah, 1 is like the biggest and 0 is, I don't know. But yeah, I'm not sure anymore what was the thing, but yeah, you see that 0 is only device local, and yeah, I'm not sure.
Yeah. It's huh. Let's ask Gemini then.
Yeah, ask it about.
The data pointer be a direct pointer to the GPU, or let's see what it says. Based on the data pointer you get from it is not direct pointer to GPU physical memory. Instead, it's a CPU accessible pointer to the region of memory that is backed by the GPU. Okay.
So wait, what does it mean now?
So let's see. Crucial points I understand. Host versus device. Yeah. Just in summary, the data pointer is your CPU view of a memory region that the GPU also has access to. It's an abstraction provided by the Vulkan driver, not a raw physical address on the GPU itself. This abstraction is what allows you to transfer data from your application to the GPU resource. Yeah, so it's kind of like it's a memory
The
address that
opposite from what I
both
thought.
your application and the Vulkan application has access to at the same time. So that the
Like
graphic,
with Vulkan driver itself, right?
yeah, so the Vulkan driver can access that, because otherwise it would do some illegal memory access,
Okay,
and that would be bad. I think the
Yeah,
operating
just
system
imagine
wouldn't like it.
having like, yeah, just imagine having Malloc in 3 for GPU, bro. That'd be like,
Well,
and it's also like all asynchronous, you know, so like not asynchronous, but you know, like everything is running on different threads, or like
yeah.
not threads, different cores, I guess.
MCC, hey man, what you doing? I'm coding a neural network. Oh shit, that's so cool. I'm just making a triangle in VR.
It also would be cool if you have like, if you can are so goated in Vulkan that you can make like a neural network and use Vulkan to train it like with, you know.
Oh shit. But that neural network, what are you writing in it? What are you using to write it? Been new hard once I was doing near command pulls. Nice. Yeah, I have done Vulkan. This is my third time doing a Vulkan application. Still, I need to get back to these Vulkan tutorials because, damn. Well, the first time wasn't, well, it was just doing the Vulkan. The second time was a Minecraft clone, and now I'm doing VR. But that neural network, what are you using to create it? How does it work? I mean, curious to know.
Assembly.
Assembly. That would be crazy. Image detector, yeah. And are you, but like, what programming language are you using? No, not assembly, in C++. Okay. How do you do image protection? Help, what am I saying? Detector. With C++. Do you have good resources on that, or because I was thinking it would be cool to write some neural network AI shit maybe sometime.
Are you
Maybe.
are you doing it from scratch, or are you using like what's called this one neural network library?
I don't know. Just starting. Wait. Okay. He's just starting. Okay.
Okay.
I will continue reading.
Oh, TensorFlow. It's called TensorFlow.
Yeah.
Yeah,
But isn't that one Python, or am I stupid?
no, it's written actually in C++, I think. And it's like, so the main bindings are for C++.
Oh, damn! So I'm stupid. Okay. No, he says from scratch. Pretty cool. Pretty cool. Pretty cool.
Oh,
I want. I want.
from
I
scratch
want.
is nice.
You need to join my Discord and tell us more about this because that's too cool to not talk about.
Crazy Discord marketing.
Yeah. Sigmoid Night, right? Oh. Wait, doing Sigmoid. Oh man.
Sigmoid is this activation function.
Yeah. Oh yeah. I remember. But
This
I don't-
cool looking one.
That's cool. But don't. I don't know. I don't like Discord. But you don't have to like Discord. You just have to get there and
You have.
you just yeah like Relu.
Nah,
RELU. You just have to join the Discord and then you're there with us and that's if that ain't cool. I don't know what is cool. No, before we come on, you can join there and you can just we have a forum where people can share cool projects that they do.
have you seen the latest updates from Xorbit's operating system?
Oh, I haven't seen it in a while actually. Oh wait, I saw it yesterday. Has he done more?
Okay, I think he has shown like one more.
Bruh. Oh, he got Doom running. He has a calculator on his. Yo, let's go.
Yeah, actually looks better than Windows calculator.
Actually, it's not offset.
Yeah.
Oh man. Crazy guy. I'm sending all this memory shit in C. Damn, yo, Doom. Yeah. Don't worry about it. But you can still join the Discord, please. I just need somebody who knows about neural networks and in like C++ or somewhere around those lines because I don't know. I don't know. I love pointers. Pointers are like I don't know. I don't understand like why people dislike them because I'm like it's so easy when you pass a pointer to a function you can just dereference it and just you know what you're dealing with.
Void pointer.
Yeah. And you just know that you're dealing with you just know
pointer.
that you're dealing with a pointer, and rather than having references, because I feel like solos, I'm like, am I working? Well, you can pass some by value, but I'm always like, am I working with a value here, or am I working with a reference? And my brain is always like trying to understand what am I doing here. But pointer is so clear. I don't know shit in neural network. Well, you're making one, so you know more than me. I haven't even tried making one. So.
Because are you familiar with move semantics in C++ and like R value things?
Move semantics.
That's like yeah.
Wait, is that the when you move the like ownership of a pointer? I don't remember.
Yeah, like the ownership of things. Yeah.
Yeah. No.
But like with like the R value stuff, with like the double ampersand.
Yeah.
Have you seen that?
I have
okay.
I have done some, but it was just briefly. I remember because I watched like 5 videos on it because I had to understand it for some assignment. But then I was like, forgot about it after that. Okay, I might come to your Discord. Might VCW. I might create an account right now. Glad to hear you coding shit seems insane even in VR. GPT Quest 2. GPT Quest 2. Yes, it's a bit interesting because I have to refresh so much every time I try to do a Vulkan thing. you have a Quest 2. Amazing. Then you can also play test the game once it's done next decade.
Yeah.
No, we will get it done within I think the game will be done within before August ends. Maybe halfway through August. Best case scenario. That I believe. Because it won't be like anything too extreme, but it will be something simple that it just feels like a game in VR. What's the command or... Oh, I think I have... Don't I have it in the chat? In the Discord? You should be able to see it here. Will it release before Carlson? It will be released before Carlson. I can still put the link here. Let me just take it. Boom. Boom. I hope the link is still valid. I think that's a forever and ever link, you know. Oh, flashbang.
That's a sound
Oh,
effect.
no worries. And share your neural network journey because I wanna get into that, but I'm still like a bit stuck here with the Vulkan stuff.
Lucas neural network for the VR game? Question mark.
I think that's I need to make a video also, you know,
AI
at some point. But I guess I
Yeah.
could make it
AI
like a part.
enemies.
Yeah, I could make it for part 2. Still streaming? Wow.
Oh yeah.
Yeah. Yeah, I'm still streaming. It has only been like not even 5 hours, so don't worry. The night is young. We got plenty of time. That sounded so weird how I said it, but you know what I mean, all right? Still gonna be streaming. I don't know. I should go to bed, but oh fuck, I got leg day tomorrow. Oh fuck, I got a meeting tomorrow. Oh fuck, actually shit.
I got leg tape today.
Do you have holiday? Yeah, I have actually summer vacation. So yeah, school is starting soon,
By the way,
or university.
how long do you have the holidays there?
I think towards the end of August, if I'm not mistaken. So
Okay.
yeah. Then university is back on, and then I'm gonna do math and shit. Yeah, physics. I'm gonna become a smart boy. Not really, because
Finally, no more Java.
yeah, I think there won't be more Java because I did the switch from computer science to computer engineering. So okay, I'm on your Discord. Whoa, let's go till the end of August. Yeah, bro, I haven't been to the gym in a few weeks. Probably should go tomorrow. Yeah, you should. Gym is awesome. Gym is like, I don't know, it's awesome. Okay, you get to train, you get to lift, you get to evolve, you get to become a huge person, and who who wouldn't want to be that? Yeah, nailed it. My semester starts in October. Damn. But I have exams still. Okay. Gym is life. Gym is life. I only go 3 times a week, though. I should be going more, but I want to focus more on this YouTube stuff. So I try to just go for maintenance. So I just go to not lose my gains. Yeah. I just want to figure out like what kind of stuff I should create and what I should make a video about and how I should live stream. So I've spent a lot of time just researching this. Hi, I'm in your VC, can't speak. Yeah, I give permission for people to speak after I kind of know, have spoken with them at least one time, just to be sure that, you know, nobody who just comes and say something weird during the live stream. Just a safety measure. Don't worry. You probably just talk with me once and you probably get permission to talk. In this channel. You can talk in the other channels, but the live stream one I keep with permission block. I come to a conclusion that man needs only 3 things: gym, white monster, and hardstyle. What is hardstyle?
Music genre. Don't you know it?
No, I don't.
Like heavy electronics, I think, like stuff like that.
Yeah. Okay. Yeah, that I agree with. I haven't drinking energy
boy.
drinks though in a long while.
I think I have drank one energy drink in my life.
What? Okay, I have drank more than that though, but I haven't.
Water on top.
Water on top. Yeah, of course. Actually, milk is also pretty damn good. You know, it has more calories. It even has protein if you really think about it. It's a
But
bigger
is it
win.
transparent though? Can support my transparent windows like Wayland? I'm not sure about.
True, that's true. What semester are you in? Help teach us how do I translate European to university to semesters stuff? I don't know. How does this work?
What?
Like, what is a semester? Help me.
Like half a year, you know.
Ah,
Like there's summer semester and like winter.
what? Where are you from? I'm from Finland. So yeah. I don't know. I don't think. Oh wait, semester is like okay. Wait, yes, but I don't know. We just call it like, what is it called?
You're in the
Easter
second,
and
right?
Easter and fall. Hello, Finland man. I'm French. Oh, you're French. Yeah, Finland. But what was it? It's we have like fall and Easter, like termin in Swedish. I'm Swedish speaking by my mother tongue is Swedish. Oh, hey T-Chef. You know what? Eldin he's German. In the chat.
Hallo, was geht?
Let's see what I don't know what you said, but it sounds good.
I said what's up.
Oh, okay. Buffers in Vulcan RV. Okay. Well, but yeah, was get? We got world globe. Hell yeah. But I'm gonna start my second year in university, so yeah, got 5 years. 3 years for bachelor's and then 2 more years for masters. Don't understand German, neither do I. Yeah, I just know Krankenwagen and that's about it.
That's crazy.
Because it's so absurd. It's such a weird word.
Or it's normal.
Is it Norway? Is it? You're joking with me.
Wait, you know? Nah, it's normal, I said.
Oh, okay. Okay.
Wait, you don't know what it means?
Wait, Krankenwagen. Or
Yeah.
ambulance. Ambalam.
Yeah.
Call an ambalam.
But not for me. I mean,
This is nuts. In German, it's 3 years for both bachelor and master. Damn. Maybe un poco de Spanish and Russian, but nothing else. I'm learning Finnish at school. Oh, nice. I don't know. Finnish is a weird language. I'm just saying. Master another 2. Yeah. So I have also like bachelor 3 years, and then master another 2 years. But I'm starting my second year on the bachelor's. Well, buffering bulletins are regions of memory used for storing arbitrary that can be. Yeah, this I already read, right? No, I did not. Can be read by the graphics card. They can be used to store vertex data, which will do in the chapter, but they can also be used for many other purposes that we'll explore in the further chapter. Unlike the Vulkan objects we've been dealing with so far, buffers do not automatically allocate memory for themselves. The work from previous chapter has shown that Vulkan API puts programmer in control of almost everything in memory management is one of those things. Oh yeah, but this is Yeah, okay, wait, this is what I... No, wait, is this... Okay. No, create buffer info. This is the same thing that I just did. Yeah, sharing mode. Destroy, memory requirements. Find, and this, and then bind, clean up, fill the vertex buffer. Yeah, we got here, and then now we got here. And okay. Yeah, we got here. Brah. Binding the vertex buffer. So you're basically a fetus. Well, no, basically. Finnish just drunk Estonia. And I mean, you're not wrong. More like high Bulgarian. But yeah, I actually have been studying before university. I have been studying. I was 9 months in the army, and then 1 year studying just physics, math, biology, and chemistry, and another 2 years I just studied C programming. So, and now I'm in university. So yeah, I've been a little bit all over the place. But yeah. Let's see. So bug in your room, it's just flew by. Oh, you saw it? Fuck, yeah, it has been pissing me off. You don't know, like, I haven't even given it a name. And the name of this piece of shit is Peter. I hope nobody's name in the chat is Peter. That would be... it's not an insult. It's just... I just name everything Peter if I don't know what to name it. Binding the vertex buffer. All that remains now is binding the vertex buffer during the rendering operation. We are going to extend the record command buffer function to do that. So command pipeline, graphics, and then vertex buffer, offset, bind, and then you bind it, and then you draw it. Yeah. Hey Peter. Exactly. Did you hear that, Peter? They're saying hello to you. Fucking piece of shit. The ec command bind vertex buffer function is used to bind vertex buffers. To bind is like the one we set up in the previous chapter. The first two parameters besides the command buffer specific offset the numbers of bindings we are going to specify vertex buffer for. The last two parameters specify the array of vertex buffer to bind the byte offset starts rendering vertex data from. You should also change the call to vkdraw to pass the number of vertices in the buffer as opposed to the hard-coded number 3. Now run the program and you should triangle again. Try changing color of the top vertices. Alright. Let's see, in here, so that means they just continue on here with this thing. With the rendering resource now set up, we can add the code needed from the Cuboids. We will set up Cuboids. We will set up the render cuboid method, which is little help method to render the cuboids. Also tracks the number of render cuboid index. This is used to set the correct. But I don't think I will just do a platform. I will not try to do another one. Inside cuboid, add the following code. Create that translation rotation scale made the multiply constant color set camera UV camera set pipeline. Oh no, now they're using a bunch of their own API calls again, so I have to go figure out what the fuck they're supposed to mean. Set descriptor, update descriptor, set vertex buffer, set index buffer, draw index, and render cuboid. Yeah, so this is basically what I just read on the other page, but this has a lot more to it. Vertex buffer like layouts. in OpenGL. Yeah. There's like they are associated with the layouts. This is gonna be awful. I just feel it. Bam. Here. So they have render cuboid like this, and it takes in the pose, the scale, and the color, and then you use the member functions to all of this, set descriptor, buffer data. Set buffer data. Huh. Is there a lot of difference between OpenXR and Vulkan? I don't know anything. I think OpenXR is pretty close to like there are subtle differences, like in the I can show an example. So oops, no why can I not? Okay, boom. So create instance, for example, here I know this because in here it's just a C pointer, and if we take the OpenXR instance, like they're quite similar, you can see similarities, but application name, it's like this is a small like it's kind of like it doesn't really why, you know, but so in Vulkan it's just a C pointer for the application name, but while in OpenXR it's an array of characters for the application name, and I don't know why. Maybe it's just it's but it's still like they are very similar. Like you can see like it has the same kind of setup. And then another thing that is really interesting also in OpenXR, which I found, sadly it broke, but I was trying to get this thing working. I haven't gotten it yet, but because I was trying to do C-style programming while we're using SIG, so that's why. But let's see here, let's go a little bit more out. So when you get the Vulkan instance extension, so you get from the XR instance, you get the Vulkan. Yeah, SIG, it's a modern C programming language kind of. But it's similar to C in the sense that it's data driven and also trying to be like a modern, like if C but if it was modern, and it's nice. It's it's a little bit more explicit, I think, or it is more explicit than C, so that's why I like it. But yeah, you get all of the extensions, and it's actually a single string which just have spaces in between each extension, while in Vulkan, I don't remember how it's there, but I know it's not like this. So what I tried to do here was that I just set the last element to be a space, and then I went through the for loop and I checked if it's a space, then I would just wait, where did I do it? I would null terminate it here, and then I will append from the first extension data, and then from like this position where it was begins, and then where I found the space, which I replaced with a null terminator. But for some reason this doesn't work, and what that would allow me is to have a list of pointers that I could just pass to the Vulkan instance. But I don't know, something here is fucked. I'm leaving it for later because it's not really. I just need it running, and I just hardcode the extensions that I need right now, which this function should figure out to give me. But it's fine like this for now. I will get back to this soon when I start to refactor this whole thing. But yeah, for now this is how we'll deal with it. Now I need to figure out what all of these things mean? Like, what are they thinking? I'm not gonna go and check what this create translation rotation scale, like, that. Maybe I need to figure out what it is. Here. Wait, see. Why can I not see what it... Oh, this is the function, okay. Damn, there's so much stuff that's going on in this place. Well, I guess I could easily translate all of this, what they actually mean in SIG as well. Doesn't look too complicated. But yeah. Let's see, what else do they do? They do that, then they create this. They do some color stuff and offset cameras. Now they have the camera constants render cuboid. Index. Okay, yeah, so you just... I guess I will just take offset camera UB. But why would you take size of this? Because this is a struct, I assume. Yeah, that's struct. And you take the size of it and multiply by it, so it will be 0 for the first, and the second one will be like some crazy weird ass value. Set.
Wait.
Hmm?
I'm gonna switch to Linux real quick. Be right back.
All right. Oh. But why would you take a whole nother memory segment for this? Or if you have multiple ones, why would you pass different camera constant? The same information should be valid for all of them. Or am I that stupid? Anyways, this is not relevant for me, and I have a different way of dealing with this. Set pipeline, so you can change the pipeline. Damn. Then you set the descriptor to be uniform buffer vertex. Live steal and still don't know to fix this fucking triangle. What? No, I'm not. The triangle is way gone. We're not trying to fix the triangle. We already got it. We are trying to do 3D rendering now. Oh, you can't. I'm usually streaming. Yeah, I guess I am. I should actually go sleeping too when it hits 10. But, you know. Pig, do you have your validation layers on? You should look at those. Those are really helpful. I'm just checking if you do, because if you don't, then that's a big blunder if you don't look at them. They are really important. In France it's 8:54. Damn. What do I have didn't listen? Do you have validation layers enabled? Like in your let me show. Let's see. I have it in the you don't have it like this, but you here. Wait, these are the extensions. Why do I have call them both extensions? Instance, where do I pass?
Oh,
Ah, you're back. Validation layers here. Do you enable this? So you have this. This is all I got. Maybe there's other ones, but at least this one is really good. So pass this layer. So when you create the, oops, shit, I don't know my shortcuts. So when you create your instance, Vulkan instance here, you pass in the layers, and then here you have to take them in, and then you just do here layers, you pass them enable layers names and then the count, and then this will help you a lot. So you should pass in your that thing. They are really good, and also there is a better way to do it. If you don't have to do it like that. You could also just do let me see, where do I have the bye guys, I'm gonna watch something else. My laptop's so slow. Hope get back to my RTX PC. Hate holidays. Alright, see ya. Take care, MCC. There is this thing called how can I get can I see my Vulkan info Linux. I think it's called Vulkan info as it is, but yeah, it's literally just this Vulkan info. Or was it dash? No. Wait. I know it's something like this. Or is it Vulkan tools? Wait. There's like an application that you can start to enable. No. The program can enable. Just want to get CMake working to. Oh my god, I can't actually find it. VK config. VK config GUI, not HUI. Do you want to resolve this? All layers configured will be lost. Yes. Do you want to download Vulkan? No. Okay, here. So you can see here. Rise, yeah, in the dark. Yeah. Oh yeah, it's really dark actually. But here you can, if you start VK config GUI, you can go in here, and well, I guess you can select different one of these. But here you can enable. Include Vulkan load messages and then the errors and then validation. Wait, there should be here. You press this one, and then you don't have to do it through code. Instead, it will just enable the layers through here. I just prefer to do it through code because, yeah, it feels like you know what you're doing. That's a good one, isn't it? Had to Gemini that actually, so yeah, I know what I'm doing. But try that and see what you can get from that then. So this one will just push back word disk set. Tool descriptor binding. Okay. if type buffer, if type image, if type sampler, and then they just put buffer. Okay. And then buffer create info, buffer size. Okay, and they store. That's why they store that. Okay, now I'm starting to see. And but what's the point of doing all of this if you're not gonna use it? What? Oh, but it's a ampersand. But they don't do anything with it. What the fuck? This is confusing. Okay. And then they set the descriptor, then they update them. Which is from Vulkan here. Okay, allocate descriptor sets. Yes, probably. Yes, pipeline layouts. Get VK set pipeline. This is 2 C++. Oh my god. Vertex buffer. Yeah, I could probably make a function also to render cuboids. But I will not. I can follow the same gist, kind of, but where does this happen? It happens after destroy swap chain. No, wait, these are just function. Okay, I was like, the fuck? Now I'm reading something very wrong. So where's the actual main function? Okay, here. So app run, create instance, system ID, all events, render frame. And then inside render frame, they do all of these, render I. Render layer, acquire swap chain. Here they do all of this, projection, begin render. Could be actually here, clear color, clear depth, set render, attachment set, create projection. No, render cuboid here. So they do it after they have, yeah, set up that, and then just before release. Yes, I'm starting to have. Oh no, tomorrow is another day, and I try tomorrow. Yeah, that's why I'm starting to have cancer. No, bro, Vulkan is. You have to be patient with Vulkan. There's always more to learn, and yeah, it's even basic concepts takes time, but I think it's worth it. You know, it again depends on what you actually want to do. I just really want to I just want to learn how a VR game is created without an engine. Like, I don't really care. Like, I just want to know in the best manner, like most knowledgeable way. Maybe I should have done this in assembly. No, that would have taken me years to get this working then, but in a somewhat kind of good way how this actually works. So that's why I'm doing this thing. And you just need to find out like why you want to do stuff in Vulkan. You know? But yeah, I'm gonna do this, so just before render I. Oh, and render I. They have such a different way of doing this whole thing. But I'm gonna do it down here. I started to have, because that total just triangle I want. Just get the triangle. You can get it. So begin command buffer, command barrier. Here do the read. Oh yeah, but this is not for the actual rendering yet. Here, export, begin render flame. And we have the input. What the fuck sense? Yeah. Then we do the render. And I probably need to do render eyes separately for both of these. Yes. Acquire swap chain. So wait. Map memory. So now I got the memory for the eye stuff. Oh, fuck's sake. So I need to be before set scissors. Scissors. Bruh. For render attachment. No. That's the action. Viewports. Set viewports. Oh, come on. Okay, so here, before that, let's go to the set viewports. Vulkan. Here. Viewport. Yeah, so before this call, and probably before set scissors as well. But, or like after that, but before that one. And render pass. I'm a bit unsure. Should I do this in the same? Oh yeah, it should be, because this is what I want to change. Literally this part. I need script shader at super start or later to render more on the GPU. In Python I could have half game made in half day. Here I have one thing, fuck that shit on. I continue that. God bless you. Thank you. Yeah, in Python it's quite easy. You just can literally just do an import and then you have the game. Almost it feels like that. But it's also more fun like this, I think. Like I have done stuff also in Python, but I don't like Python because of the things just work, but you don't really like. I don't feel like I have control of what's happening. Not that I have much control here either, but I have way more than I would have in Python. So.
Yo.
What are you saying, dog? Yeah, I just have to replace this with the call to draw the those things. From the past, I wanted I want faster and anyway, I don't know how long you're gonna stay, but good night. Good night, Null the Pointer. I will probably go soonish. I should actually go because I need to hit the gym and I'm gonna have a meeting tomorrow, so yeah. Let me actually just do this. I'm just gonna git branch. I'm probably on the master branch. No, XR refactor.
I should probably not be on this branch. This is not what I'm doing. It's whatever. It's kind of like an XR refactor actually, when I think about it. This is the wrong project, bruh. Thank you for no the pointer. Thank you for pointing out the time. I should really be going. Let's see. I think I have XR refactor. Yeah, I will just push it. It's still related to it. Git dot git commit -m don't run.
So the amount of branches or like local branches is so insane. I also have so many. I need to delete them, bro.
Don't run transferring data is not working. Git push. It's just a backup for me in case if I somehow decides to destroy March Linux tomorrow morning for some funny reason, you know. But yeah, it will be done in here. I will just to do here we do the cuboids. I hope it's like that. Yeah, but we can do git check out before I go master. That's shit. Git add dot git com meet dash reminder. I don't know. Git checkout master. I can't spell checkout. Help me, guys. Alright, and then sig build run. Just to show you guys before I go the beautiful triangle has been there for a long while. Probably gonna stay there for a long while. Oh, the master doesn't run with the validation layers. But yeah, there you can see. And oh, whoa, there's the triangle. You can see I have the headset here. You can clearly see that I'm holding a headset, right?
Yeah.
And it took such a long time trying to get the spectator view, because what it does, we render first the virtual reality, and then we take the information from the VR view, copy it over to a Vulkan render pipeline, and render it there, or a graph swap chain. Like I have two swap chains. I have one for the XR and one for the Vulkan. And that took so long to get working, but it is working. And I did it mainly.
Wait, but how that works is that you basically render the triangle in Vulkan, then you make a connection to an XR swap chain and a connection to the Vulkan swap chain, right?
Yeah.
And okay. So basically just split it up like at the swap chain part.
I can show like in here. Let me. I don't remember my key bindings. Actually, let me also just git check out XRB factor. So I will be on the right branch when I get back tomorrow. So here you can show it goes down here. We initialize the Vulkan swap chain, and then we have an XR swap chain.
Okay.
And then I just create basically, because the Vulkan just needs a command pool, it doesn't need any of these stuff, because this one, the XR swap chain, it will contain a, am I tripping? No, I'm not. Here. It's containing here, it should be there. So it has this thing, VK dupe image. So this is where it will have its, because I don't want to use the same image. I have a separate, like I duplicate the image here, so I have one for the, this is for the actual XR, but this is for the Vulkan inside of the XR swap chain. So one is for the actual XR render, but because I don't want to be accessing this memory at the same time that I'm trying to
copy it over, like, so that's why I have this one which just does a copy. So I don't think I do anything with it over here, except for VK image, if I remember correctly. Dupe. What was it called? I already forgot the name. VK dupe image. So I basically just allocate it, right? Yeah. Yeah, that's literally all I do here. I just bind it here. But then in here, I do this. This is the command blip. So it takes the source image here, this thing, and then it copies over it to this one, which is the Vulkan swap chain, right?
Okay.
And I don't know why I could not just use the actual Vulkan or the XR swap chain image, but I read that it was something like they tried to copy it at the same time that the graphics card, or like when it tried to render it or something like that, went wrong. But
Or
yeah,
isn't it because also of like both eyes? So is that like coming later completely right?
yeah. But here you can see, so here we have the actual, it's image.image.image. Quite funny. But
What is that? Image.image.image. Whoa. Whoa.
because this is the XR swap chain image, right? It's and then that thing has the XR. So this is like the XR Vulkan image, and then through that one we can get the Vulkan image. So we copy it from here into this one, and yeah, it's a bit interesting, but at least it's working. It's so weird. I would like to move this whole code section away from here because it's kind of like, yeah. But it happens after all of this, so I think it should be fine if I just used raw. I wouldn't have to do, but I do it anyways. Took forever, but I got it working. Pretty cool. Have to super fast code like in C++. I'm going against Deep CU. Alright, tomorrow you can help me more a little. How I will save Haxios and love it. Alright, but tomorrow well, I also started today late. I was struggling with Docker Compose, and I still, well, it works, but it's my Mongo database that is bullying me for some reason. I spent like 3 hours trying to fix it, and I didn't get it fixed. But I got a AWS server working for a Discord bot, so that's pretty good. But yeah, I didn't get the database information transferred, sadly. So we're running a clean slate. Maybe it's good. Because I should nerf the bot. It's quite OP right now. All right, but I'm gonna go sleep.
The bot?
Yeah, I'm gonna end the stream. Do you want to say something, T-Chef, to these amazing people who are still here? Maybe.
Bye chat.
Bye chat. Let's see.
Bye bye.
Should I do can I do a raid? I have never done a raid before. Should I do it? How do I do it? How do I raid? How does this work?
I don't know, man.
I just want to give forward the the good. People do it for me, so I would like to do it to others. Why am I just does anyone know how to raid? How do one raid? Raid channel. Let's see. Let's go to let's make a chat protocol server. Okay. Let's take freeform programming. Survival game.
This develops from scratch still
Oh,
online.
I don't know actually. Search develop from scratch. That's not. Damn it. Well, let's go to.
Right, okay.
Is there something really interesting? Nobody's talking about like something like C in the thumbnail. Game dev banter practice preparing for content creator arc. That's pretty banter. I'm gonna let's go for nobody's saying anything. Maybe the only people who are watching AFK. Oh man. Let's go for the this one. This looks good. How many? 18. Well, let's go. All right. Start right now. And then I will stop the stream here, but yeah. See